How about that? Nope. How's that? Is that better? Thank you so much for letting me know. Oh, oh, hello. What is this one? This one is okay, good. Thank you. 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 I do appreciate it. So we have our next number, and this is, oh, I was just saying that I created this thing and I don't remember what the answers are. So we're going to look through it. We have this number. What number do you think this is? So we have our tens and we have our ones. We have our tens and we have our ones. What number do you think that is? Thank you, Israel. Thank you, Jess. Thank you, Reaper. Thank you, King. Welcome, everybody. Welcome. Thank you so much for joining. Thank you. Tap your screens. Oh, I would love it. Yes, please. Thank you, everybody, for tapping the screens. What we're doing is we're learning how to read the abacus. That's what we're doing. So, what number do you think this is? We have our tens and we have our ones. So I have to, yeah. Is it 22? It is not 22 because the top beat is a value of 5 and the bottom beat's a value of 1. So together, this actually makes 6. So the top beat is a value of 5 plus 1 is 6. And then we have the top beat of value of 5 and we have 2. So this is actually 7. Hello. Thank you, Drisky Go Crazy. Drewski. Aha! Thank you, Drewski. Go crazy. Ha ha ha. So it's actually 70. It is 6. Because the 7 is over here. So 5 plus 2 is 7. And then 5 plus 1 is 6. So 76. And I got to color in my pixel art. So I have this thing. I don't know what it's supposed to look like. It's been so long. All right. We're just working our way through. So this is another puzzle. This is another puzzle that I created. I just don't remember what the answer is. So what's our answer here? This is our tens. So if we have one, so 1, 1, 1, 1, there's 4 of them. What is this number right here? Thank you everybody for joining. Thank you everybody for joining. Hello. So what number do you think this is? It is 40. Thank you. Yes, Israel. Thank you, Iggy. Vanessa, don't forget that the 0 here is a placeholder. So thank you, Reaper 13. Yes. So the 0 right here, the reason why is because this is my ones place. So very good. You almost got it. But here, we have to remember this is the ones place. There's a little dot. If you notice there's a dot, this dot tells me the ones place, and then this is the tens. So we have our ones and we have our tens. Yeah? Make sense? Let me know. And then if you notice, we actually have 2 dots. There's a tens over here. I'm sorry, the ones over here. And this is the thousands. The thousands is like the comma. So what is our next number? We have our tens and we have our ones. I don't know. This is exciting. I don't know what I'm supposed to be picking up. So what number do you think that is? Show the label. Oh, hold on. If I show the label, then you can't see the question. Thank you, Iggy. It is 35. So, just so you know, the 5 is the top beat. The top beat will always be a value of 5. 31 actually looks like that. Yeah. So 31 looks like that, but this was 35. We had 30 and we had 5. When we have the top beat as a value, the top beat is touching, that's what's considered 5. And then anything on the bottom beat, it is a value of 1. So it is 30, it is 5. All right. So this is, I don't know what it looks like. I don't know. I don't know. Hello, Jen. It's always, Jen. How's it going? How's it going, Jen? Okay, sorry. So we're going to continue on. I'm doing a puzzle that I created so long ago and I don't know what it is. So you guys are helping me figure out if this is all correct. What number do you think this is? This endless mind is an abacus. This is a counting tool, and what we're doing is we're visualizing our numbers. The abacus helps you visualize your numbers. What number? Thank you, Iggy. Almost. It is not 47. It is, hello, Nat. No, it's not 42. It is 7. Yes. 5 plus 2 is 7. So that's 7. So we have our next number. This is a 2-digit number. See, this is my pixel art. I don't know what it's supposed to look like. I don't know. So that's what we're doing is we're trying to figure it out. Ooh, sorry. 90. 90. I already gave you some of the number. What number do you think that is? Yes, thank you, Nat. It is 90. It is 6. There we go. So we have, that's what it looks like so far. 96. Lottery number. Yeah, maybe. Thank you, Jess, for the rose. Thank you so much for the rose. I see you, Jess. I see you. Yeah, it could be lottery numbers. I don't know. So we have our next number. What do you think that is? I don't know. Okay, what do you think? 46, it is 80, it is 6. 80, so we have 5 plus 1 plus 2 plus 3. Sorry, 5 plus 3 is equal to 8. 5 plus 1 is equal to 6. So when we're looking, it is actually 80, it is 6. Thank you. Israel, if it's 40, it would look like that. All bottom beads would be touching. That's what 40 would look like. But here, this is 86. Thank you, Nat. Thank you, Iggy. Thank you, Jen. Thank you, Reaper. So that's what I got. Hold on. 86. So I got, I don't know. All right, what's our next number? So thank you everybody for joining. Thank you everybody for joining. What we're doing is we're visualizing our numbers. After we visualize our numbers, we will go into some adding, subtracting, multiplying, and dividing. You can actually multiply and divide on the abacus. Thank you. Yes, Roy. Yes, Nat and Reaper. Yes, it is 5. That's what 5 looks like, and that's what my picture looks like so far. So what is our next number? So we have our tens and our ones. We have our tens and our ones. So the idea is to be able to see your numbers, to visually see your numbers. Okay, what do we have? Yes, thank you, Roy. Hello, Joseph. Hello, Joseph. Thank you. Thank you, Reaper. Thank you, Roy. Yes. So that's what I got. Maybe it's a hammer? I don't know. If I had a hammer, what number is this? Okay, so I have to fix that one. It is. Thank you, Roy. It is 40. It is 9. So the bottom bead's a value of 1, 1, 1, 1, 1. This is the horizontal bar. Anytime the beads are touching the horizontal bar, great, I think. So anytime the beads are touching this horizontal bar, that's what's being counted. So we have the top bead is a value of 5, and then we have 4 bottom beads. So we have 40 and then 9 plus the 5 and the 4 is equal to 9. Yeah, thank you. Hello, Abraham. Look, hello, Abraham. How's it going? How's it going? We're doing a new puzzle because I like puzzles. What number do you guys think this is? Yeah. What number do you think that is? Can't hear the. I can't hear the words coming out of my mouth. It is 6. Yeah, the sirens are overbearing. I will tell you that. So we have our next number. All right. What is our next number? 56. Yep, 56. So this is what it looks like so far. Thank you, Ivy. Thank you, Roy. It is 56. So I don't know what this is. I don't know. 56. I only have so many more things to do. So I don't know. I don't know. Maybe it's just maybe it's just nothing. Oh, that would suck. Oh, you know what I could do? Oh, I know what I could do. Okay. So we have, okay. What number is that? Yes, thank you, Ivy. It is 38. Thank you, Roy. It is 38. So 38, that's what it looks like. I colored in 30. I don't know what it is. Hello. Oh, hello, Limitless. Thank you, Alpha. Thank you, Limitless. I was like, get some sleep for school. Bye. See you later, Abraham. Thank you so much for joining. Thank you so much for stopping by. Thank you so much. I do appreciate it. And I like to see my students. Oh, so what is our next number? There we go. I will join tomorrow. Oh, not a problem. It is. It is 30. Thank you, Ivy. It is 30. Thank you, Roy. Thank you, Tina. I don't know. Where do you get bingo from? Well, we got this one, so it's probably some sort of, maybe a tree? I don't know. But there's not enough, there's not enough to be trees. What number do we think this is? The bottom bead's a value of 1, and the top bead is a value of 5. Thank you, Ivy. Hello, Votive. Hello, Votive. Yep. We're just working on a new puzzle that I kind of trying to go through. 33. Thank you. Thank you, Weinstein. Winstein. Thank you, Jen. Thank you, Roy. Thank you, Tina. Thank you, Ivy. I don't know what this is. All right. Thank you, everybody, for joining. What we're doing is we're reading our abacus. We're learning how to read our abacus. We have our top bead is a value of 5, the bottom bead's a value of 1, and then we have 1. So we have our 10s and our 1s. What number do you think this is? I don't even know if I can draw this correctly. All right, what is it? It is 19. Very close, Fisher. Very close. 18 looks like that. That's what 18 looks like. 18 is 1 and 3. We actually have 19. 1 and 4. Thank you, Tina. Thank you, Ivy. Thank you, Roy. Maybe an arrow? Maybe an arrow? Maybe a mushroom? I don't know. It is 19. Well, I only have 1, 2, 3, 4, 5, 6. We only have 6 left. I don't know. I don't know. It's been so long since I actually did this one. Thank you so much for joining. Hello, everybody. Hello. Thank you, Jess, so much for the roses. Thank you so much. I see that. It is at 31. Okay, wait. So it's 30. So we have our 10s and our 1s. I might be overthinking on the page, but 26 in the outer book utilizes the 5 bead. Okay, hold on, Votive. 31. 31. Yes, 31. And then our next one. Let me see. In the adult book utilizes plus 5 bead. Okay. Is it 4? It is 4. So we have 4. Okay. Let's finish this one, Votive, and then we'll go into the thing. So that's what 4 looks like. Yeah, I don't know. It's just a bunch of dots right now. So what's our next number? We have that one. What number is that? Yep. What are the blue beads? The blue beads is a value of 5. That's a very good question. Thank you. Hello, Machiavelli. I'm feeling better. I am feeling better, but sometimes I get my cough. Thank you so much for asking. Thank you, Ivy. Thank you, Tina. Yes. So the top bead is always going to be a value of 5. The bottom bead's always going to be a value of 1. So we have 5. So this is actually 13. Thank you, Tina. Thank you, Ivy. So when we're looking, this is 1, right? If we add the 5, this is now 6, but it's not. Right? So if we have 3, 1, 2, 3, we add the 5, and then it's 8. But the answer is 13. So this is what it looks like so far. I don't know. Is it a key? I don't know. Okay, what's our next number? What is that number? I don't know. I don't know. Okay, what is it? It is not 10. Actually, it is 5. How do you represent anything over 50? It is not 5. It is not 10. It is actually 50. So the top bead is a value of 5. What are your plans for tonight? Oh, thank you so much, Machiavelli, for asking.
Gee, Ray, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
Thank you, Tina. Thank you, Damien. Yes, it is 50. It's a 5 and a 0. The top bead is a value of 5, and then anything over. So if this is 50, then it would be 60. So because we add the 1, that would be 60. And then this would be 70, 80, 90. And then we would have 100. So every column is our 1s, the 10s, and the 100s. 1s, 10s, and 100s. The reason why we have that is because we have a dot right here. Thank you, Ivy. This one right here is the dot. This dot tells me is my 1s place. So we have our 1s, 10s, and 100s. So when we're looking, here's a little place value label. So we have our ones, our tens, hundreds, thousands, and 10,000s. Between the ones and the tenths is our decimal. So this would be our decimals over here, our tenths, and then the hundreds. Let's go. Oh, thank you, Jess, for the reminder. Please, for those of you that are enjoying the content, please tap the screen. What they say, tapping is clapping. So we're almost with two more. I don't know what this picture is. I'm just letting you know. I don't know what this picture is. Maybe somebody could be letting me know. Maybe you guys see something that I don't see. What number do you think that is? Thank you so much. Thank you so much. Yes, it is Michael Myers. Thank you. Thank you, Michael. Thank you, Ivy. Thank you, Israel. Thank you, Tina. It is 22. And maybe it's a tree. So what's our next number? What's our last number? Huh, maybe. Maybe, what do you guys think? So we have our last number. What number do you think that is? So we have our 37. Yes, thank you. It is 30. It is 7. So when I color it in, what do you think? Maybe it's a tree? 37? Yes, Michael, it is 37. What do you think it is? I don't know. An umbrella? An umbrella! Yes! Yes! A hammer? Man, I can see the hammer. I can see the hammer. I see the umbrella. Thank you, everybody. This is pixel art. It's been so long. So I know I need to like redo some of this part. But yeah, make it a little bit more symmetrical. An umbrella. I love the art. Thanks. So what we did was trying to figure out what this picture. I gotta see what it was. Is you guys were helping me correct to make sure that I have the correct numbers, and that's what we did. So what we did is we understood how to read the abacus. 1, 2, 3, 4, 5. There was a lot of numbers, and so this is one of my activities that I'll be having in my new book. And so the new book would be doing some pixel art, and so that's what it would look like. There you go. Yeah, 58. Yeah, I see that. 58. Are 58 and 59. Yeah, there's a little bit of discrepancies that I gotta fix. So, but at least I know what the numbers are. All right, so votive, you said 26. Yes, 26. Yes, we are utilizing the 5 bead. So this is my Abacus for Adult book. This Abacus for Adult book is available in my TikTok shop. Thank you. Yeah. Are 48 and 50 right? No, they're not right. Because it's supposed to be 49. Yeah, and then there's supposed to be this one here. So what I'm going to do is I'm going to fix this up a little bit. And it's been a long time since I've seen it. So, Votive, are you still here? So when we're looking, we go into how to make a 10, how to make a 5. So that's correct. And what are you overthinking? This is what we're trying to do, is we're trying to figure out how to make a 5. This is the idea. So this is the lesson. So this page is a lesson page. And what we're trying to do is we're trying to understand how to make a 5. So we have 4 on the abacus, and we want to add the 1. To add the 1, we have to plus the 5 minus the 4. Yeah. What was wrong with it? Did you not understand it? Utilize the top 5. Yeah, utilize the plus 5 bead. There aren't enough beads, so we can utilize it. We want to add the 1. When we want to add the 1, use your index finger to push the bottom bead down and push the 4 beads down. So when we're looking, this is what we're doing, right? And then we could do it again with the 2, right? So we have 4 on the abacus, and I want to add the 2. When I add the 2, what do? I have to minus the 3. So when I minus the 3, I do this, minus the 3. So my final answer is 6. Thank you, everybody. Thank you, Raquel, for the reminder. Thank you for the reminder. Thank you, everybody, for tapping it. I should be in bed. My brain won't shut off. Oh, yeah. But the page is correct, though. The page is correct. Thank you, Raquel, for the reminder. Thank you, everybody. We're at 10K before 30 minutes. You guys are awesome. Thank you so much. Thank you so much, everybody. Thank you so much. I do appreciate it. So votive, when we're looking at it, yeah, this is correct. We have the 4, we have the 1, the 2, and the 3. Yeah, thank you, Tina, for the you're awesome. Thank you, Midcat. for the roses. Thank you so much, everybody. Thank you. I do appreciate it. I do appreciate it. And hopefully we can get more people out to the FYP, and then people can learn how to read the abacus. This is an abacus. An abacus is a counting tool for those of you that are just joining. Thank you so much for joining. And what we're doing is we're visualizing your numbers, and we're actually looking at this book that I created. This book was meant to start the abacus for adults, and what we're doing is we're understanding how to read the abacus. So we go into the big brain notes, and then here we actually talk about how to count from 1 to 100. And then after that, we go into explaining what the tens are. And then here's the mask maze. The mask maze is to help cover up the maze that we did here. So if you know what the number is right here, then you'll see what the answer is over here. So in this question, the mask maze is meant to cover up the page. So if I did this, right, what number do you think this is? And I didn't color it in, but when we're looking, what number do you think this is? We have our tens and we have our ones. What number do you think that is? Yes, thank you. It is 88. Thank you, Votive. Thank you, Ivy. Yes, it is 88. So the mask maze is actually to help cover the path. And so 88 would take me down here, and then I go to my next number. So that's what this is. And then we could start talking about the three-digit numbers, and then I explain what a three-digit number looks like. We have our hundreds, tens, and ones. So when we're looking, we have our hundreds, tens, and ones. That's what that would look like. Oh, you can't see that. There we go. So this was to explain how to break up the numbers. So we have our hundreds, tens, and ones. The top beat is always a value of 5, and the bottom beat is always a value of 1. We have 1, 2, there's 2 ones here, there's 3 ones here, and there's 1 1 here. Together, this makes 6. So somebody had asked how to make higher than 50. That's how you do it. You just need to add the bottom number. So then we come to this, and we need to see, okay, well, what number do you think this is? What number do you think that is? We're doing a 3-digit number. And if I had my hundreds, my tens, and my ones, what number do you think that is? Thank you, everybody, for joining. Thank you, everybody, for joining. Thank you so much for the roses, Jess. Thank you, Tina. Thank you, Middle Cat. Yes, it is 573. Thank you. Oh, Jen, you are tired. Yes, it is 573. 100 would look like that. 100 would be 173. So the answer is actually 573. There we go. So 573 is what it would look like. And so then as we keep going, we are talking about our next thing, which is the 4-digit number. The 4-digit number is talking about the thousands, the hundreds, the hundreds, the tens, and the ones. And so that's the 4-digit number. I explained how it looks like on the abacus. Notice on the abacus, notice on the abacus, we start talking about the place values. This is the dot. This is a dot indicator that I have on my abacus. This is my ones. This is my tens. So when we're looking, we have this number, 1,967.32. So that's what that would look like. And so then I give you this thing. Can you explain how it works? I'm confused. Hold on, David. What is this, Mason? What is this? Again, Mason? I did algebra for 3 hours. Oh, I see, Jen. Yeah, I could see how your brain's a little bit mushed. So the idea here is a reverse maze. The reverse maze means that I'm going to give you the path. As I give you the path, then what you're going to do is you're going to notice there's a number. You take this number and you have to color in the abacus. So then we start talking about adding and subtracting. So we add on the abacus and then we could do some subtraction. Here is what we do: simple adding. And so that means that we just have enough numbers and we have enough beads, and we're going to go into subtraction. So after that, we go into pixel art. So this is more pixel art. And the idea here is to be able to find the number and then take it away. So what we're looking is if we have 8 on the abacus, this is the one that we're doing. We have 8 on the abacus. 5 plus 3 is equal to 8. The top is a value of 5. The bottom beat's a value of 1. So there's 3 ones, 1, 1, 1. So what we're going to do is we're going to take away the 3. When we take away the 3, we're going to take it away from the horizontal bar. So our final answer is 5. So this would be 5, and we would color it into some other color. And then that's what this is. It is easy. It is very easy in the beginning but the thing is what I want you to do in this book is to know how the beads move. Does that make sense? So this is my book. The book is Basic Math Abacus for Adults. This is the introduction to Abacus. There we go. So thank you everybody for joining. Thank you everybody for joining. David, did that make sense? So let's do a little review. We are going to be doing some counting. This is 1, 2, 3, 4. When we're looking, anytime the beads are touching this horizontal bar, that's what's considered counted. When we do it, you'll notice that there's a label right here. This label tells me this is the ones place. Thank you, Jess, for checking in. For those of you that are interested, go ahead and check in over at the orange heart me around here, and then you get some engagement points that TikTok wants to encourage you to do. Is this tool useful for multiplication and division? It is, Ivy. It is. You can actually do multiplication and division on this tool. So we have 4, 1, 2, 3, 4, and then we have this top bead, the horizontal bar. This horizontal bar is what separates between the top bead and the bottom bead. Hello, try your best. Thank you so much for checking in. Hello, good evening. And so what we're going to do is, this is a value of 5. When we look, the top bead will always be a value of 5. And then we have 6. 5 plus 1 is 6. If I have 1 here, I add the 5. Now we have 6. We have 2, add the 5. Now we have 7. If I have 3, 1, 2, 3, add the 5. Then we have 8. We have 4, 1, 2, 3, 4, add the 5. And then we have 9. Let's get, that'd be awesome. Let's get to 50,000. I don't know how everybody else does it, but I don't know. So we have 9. After 9 is 10. Well, how do we get to 10? 10 is our two beads. That's what we're doing. So when we're looking, we have our place values, our ones, tens, hundreds, thousands, and then 10,000s. Thank you so much, Jess. Thank you so much for the goal. Thank you, everybody. Thank you so much. Okay, so David, did that make sense? And Mason, that's what it is. Thank you, Tiny. Thank you so much, Voda, for the tiny tiny. Thank you so much. Did it make sense with the thing? Yes, kinda. We can continue on. We're gonna continue on. So, if in case you wanted to do this, we have our next number. We have 3,456. That's what that would look like. Are all the blue beads? Yes, all the blue beads a value of 5. So we have 3, 1, 2, 3. Notice that there's a dot here. This dot tells me where the comma is. So when we're looking, it's easier to see if there's a comma. That's why it's nice to see it. But if you did this, it's a little bit harder to see that there's a thousands. You would have to kind of count it out. So we have 3,400 and then 5. The top is a value of 5, and then we have the value of 6, right? We have 5 plus 1 is equal to 6. Thank you, Shane, for the purchase. Thank you so much for the purchase. So then we can take it one step further. We can do 73,456.25, right? So we have 73,000. On our abacus, we can do the 10,000s, the thousands, the hundreds, tens, ones, point, tenths, and then the hundreds. That's what we're doing. So, well, guess what? For all the blue beads, are they all a value of 5? Like this? Yes, they are. So let me help you count it out.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So it's 55,555.55. How do you know where the decimals are? The decimal goes after the ones, just how we write it. So if this is my ones, then the decimal would be here. If the decimal is over here, right? If my ones is over here, then I would shift everything over. It would look like that. This would be my ones. So then it would look like that. I'm sorry. Hold on. It would look like that, right? It'd be 0.00001. So that would be, thank you, Target Dog. Thank you. So that would be the decimal. Does that make sense? Hoof-hearted? So if I do this one to be my ones place, then everything would shift over and it'd be like that. Yep. So then if I'm taking this to be my ones place, let me help you count what this is.
99 problems, but a ain't one. If you having girl problems, I feel bad for you, son. I got 99 problems, but a ain't one. Hit me.
So this is 99,999.99. So without the piece of paper, you wouldn't know? Well, without the piece of paper, I would still know. It's whatever you deem. So if you deem this to be your ones place, then that will be your ones place. So it'd be difficult for you to cheat off of me. However, if I choose this one to be my ones place, then it is up to me. So it could be, yes, it could be 99. No, it can't be, because I like to use my dots as a label. If you were to do that, I would have to use a bigger abacus, or I would have to modify my indicators. So I have a 13 column abacus. I can actually use it for that. So when you're talking about 99,999, right? And then that would be it. So it'd be my ones place over here, and then it'd be, there we go, hold on. My ones place are over here, so it would be 999,999.9, right? Yeah, it all just depends on the dot. And if you choose, let's say you choose this dot over here, then you can have ones, thousands, millions, and then billions. So the dot is to help you label your, they called it periods. I think they called it group separators, right? Just like how we write like very, very big numbers, you use commas to help you. So the commas are there to help you label it. And so that's what the dots are. The dots are just a label. You can choose any one of these dots to be your, I like that Abacus better. Yeah, yeah, because size matters. Hoof-hearted, because size matters. But it also provides flexibility. This is a 13 column abacus, and it is a little bit bigger than my 7 column abacus. The 7 column abacus is, I would use for like the beginners, and then I would use it for like, you could still use it for multiplication, division, but it does get a little bit cramped because I like to use, when I do division, I need to use a little bit more space and a little bit more columns. So it is a little bit restricted the way that the way this is. There are a few people that do buy the colorful one because it's nice and pretty and it's nice to look at. But you don't have to buy this one to get to this one. You can do exactly the same thing on the 13 column abacus. Yep. So, I always thought it was difficult to learn. Yeah, it was great too. You explain it great though. Oh, thank you. Try your best. Thank you. And so we can continue on. Let's say we talk about tally marks, right? Tally marks. We could do tally marks. I'm going to choose this one to be my ones place. So this is 1. This is what 2 tally marks is. This is 3 tally marks. And then this is 4. 4 tally marks, 4 beads on the abacus. And then my slash is the top bead, right? This is 5. And then we have 6. 5 plus 1 is 6. 5 plus 1 is 6. And then we have 7, right? 5 plus 2 is 7. 5 plus 2 is 7. We have 8. Thank you for the follow, David. Thank you, Hoof-Hearted. Thank you so much for the follow. So we have 8. 8 is 5 plus 3 is 8. And then we have 9. 5 plus 4 is 9. Does that make sense? So let's say we want to do this one to be our ones place. And then we can do it again with Roman numerals. We could do 1, 2, 3, 4. 1, 2, 3, 4. We do 5. 5 is equal to 1 plus, the top beat is 5. Right? We do 6. 5 plus 1 is 6. We have 7. 5 plus 2 is 7. We have 8. 5 plus 3 is 8. And then there's 9. And then 10. Well, what's 10? 10 is a 1 and a 0. 1 and a 0. This is not 10. This is 55. Because every column has every number represented. So when we're looking, then there will be no 2 numbers on the same column. It's literally impossible to have the same number in the same column, because then it would just be the same number. But if it's the same number on a different column, then we're talking about place values. You know what I mean? So if I choose this one back to my ones place, then I go over here, this will be my ones. So it'll be ones, tens, hundred, thousands, 10,000s. And then we have our tenths, and then we have our hundreds. And there we go. So Okay, I think I answered everybody. Thank you so much, everybody. For those of you that are interested, go ahead and check in over the orange heart me right around here. Right around here where my head is. For those of you that are interested to continue on with TikTok and showing TikTok that you are a real person. Thank you everybody for joining. Thank you everybody for joining. So that's what I have here, and I'm just going to do a brief review, and then we're going to go into adding and subtracting on the abacus. But this is like one of the pillars is the plus 10s, and then I'm sorry, plus 5s, the minus 5s. I give you examples, and then I give you an activity. Thank you, Jess, for the reminder. Tap the screen. My hands hurt. My auto clicker didn't come in. I'm so upset. I gotta go purchase another one because mine didn't come in. So I gotta figure out this whole auto clicking thing. This is a summary of how to make a 5. You have how to make a 5. You're adding a 5 and subtracting the 5, and then we have the 10. So this is how to make a 10. Making a 10 is really what carrying over and borrowing. So carrying over, I give you an example of how to carry over, and then we have the color by number. After the color by number, I actually talk about a little bit of multiplication here. Abacus on the multiplication on the abacus just means repeated addition. What we're doing is repeated addition, and then here you're supposed to put in a formula. If you use one. If you don't need to put it in. But then here is where you put the answers. We have the word ladder, we have plus 10s, and then I give you minus 10s. So this is example of the minus 10s. And you have the minus 10s is like borrowing, and this is color by number. This is a ladder, a word ladder, and then here is the cumulative property. I give you the summary of I need one. I need one too. This is the summary of how to make a 10 and how to add the 10 or how to subtract the 10. So we do carrying on or borrowing. And then we do this workflow. This workflow tells you how to read the numbers. When we look, we want to see if there's enough numbers. If not, then you see if there's a plus 10. If not, then you add the 10. And it's the same thing with subtraction. If you know how to add, you will know how to subtract. The reason why I talk about this is because the next step is called a plus two-step equation. That means that you take the two critical equations that you learned, how to make a 5 and how to make a 10, and you Tetris your way through to be able to make your answer. And so after that, I give you a puzzle, figure out what the puzzle pieces are, and then we have multiplication on the abacus. We only go up to 9 times 9 because everything else after that is redundant. And then we talk about the minus 2. After the minus 2, we talk about the activities, and then here's a bunch of activities for you to strengthen and to practice on all of the concepts that you just learned, and that's it. And the answers are in the back of the book, just in case. There you go. Thank you. Will this help me do my math faster in my head? It will if you practice. It will if you practice. It depends on how much time you practice on it. I don't do it, but it is up to you on how much you want to do. Yeah. Those kids that do this, they're doing abacus. They just happen to see the abacus in their brain, but they also do a lot of practicing as well. I hope that made sense, Limitless. Yep. Yeah. It all depends. Okay, so what we're going to do is we are going to right now. Yes, thank you. Okay. Okay, so we're going to do is we're going to understand how to move the beads. This is my preschool book. And we'll do a little bit of walkthrough of the preschool book, and then we'll start going into how to add and subtract. Now, the reason why is I wanted to start them young, because when they start going to adding and subtracting, they already know how to start counting. So we might as well just start them with the abacus. The idea is just to expose them of what the numbers are, as well as to use it on the abacus. All my books are abacus focused. When we have our 2s, And then there's tracing, find the 2 on the abacus, the 3s and the 4s, and then I have activities. I do like the activities. I'm trying to make it a little bit more engaging. And so this is what the kids would be doing. And then we start learning 5 to 9. And then we have more activities. And again, I have a pixel art. There we go. Pixel art it is. And then we have the count and color and tracing and trying to find the abacus. So that's what this is. And then after that, we count forward. After counting forward, we count backwards. After counting backwards, we figure out what comes in between. So now we're talking about the relationship of the numbers. Here is the surrounding, what numbers is surrounding, and then after that is comparison. After comparison, then we start going into adding and subtracting. And there we go. So in this book, we're starting to do some simple adding and subtracting. When we're looking at it, we want to be able to look at our number. When we look at our number, we're only looking at what our process. We're looking at the process. We're not looking at the result. We are not focusing on the result. What we need to do is we need to know how to move the beads. So if I have 7 on the abacus, that's 7, 5, 6, 7, and want to add the 1, we're going to add the 1. My final answer is 8. Right? So when we're looking, what we want to do is we want to be able to understand how to move the beads and how the beads are moving. So if I have 6 on the abacus, I want to add the 2. Can we do it?
Yes, we can.
Yes, we can. We can add the 2. So my final answer is 8. Again, we're not focusing on the result. We are focusing on the process. And so I do have activities in this as well. There's a puzzle here, and then you have to find the puzzle piece. And then we have 3. So we have 3 on the abacus. Oh, here we go. Here we go. So we have 3 on the abacus, 5 and 3. So when we're looking, we have 5 on the abacus. We want to add the 3. You know, you could do it with the dots like mainstream math, or you could do it with the tally marks. That's fine too. However, it's not very scalable, because if you notice, I can actually say 50 plus 30 is equal to 80. How do I know? Because I have my 1s and my 10s. Notice I have my 8 and my 0 over here. So you could do the dots, but that's a whole lot of counting. Thank you so much for liking the live. Thank you so much for liking the live. Please, if you get a chance to tap it out while you listen, if it's possible to tap and listen, that would be fantastic. Thank you everybody for joining. Thank you everybody for joining. So what we're doing here is I'm showing you how it's scalable. You can take it one step further. You can do 500 plus 300, and that will give me 800. But instead, you could do it in mainstream math, which would be putting in a lot of dots. You could do that, or a lot of sticks. I don't know. Then I have how to make a 4, how to add the 4. We have 5 on the abacus. We have 5 on the abacus. That's what 5 is. And we want to add the 4. We add the 4. So my final answer is 9. Now, if you know how to add, you will know how to subtract. Well, you notice that if I have 7 on the abacus, I want to take away the 1. All I got to do is just take away the 1, just like that. If you know how to go to the horizontal bar to add, to take away, you go away from the horizontal bar. Thank you so much, everybody, for liking the live. Thank you so much. So when we're looking at it, right, the idea is if you know how to add, you know how to subtract. So if I have 2 on the abacus, right, 2 is what? 2 beads like that. But if I have 9 on the abacus, I want to take away 2. I just take away 2 beads like that. So I just take it away from the horizontal bar. My final answer is 7. And then we could do it again with the 3. We have 4 on the abacus. I want to take away 3. There we go. Take away the 3. So you're starting to see the number pattern, because patterns are always going to be the same. And then if we add the 5, right, what is adding the 5? Adding the 5 just means if I have 3 on the abacus, I'm going to add the 5. There we go. We add the 5. Now my final answer is 8. And if you notice, if I want to take away the 5, you just take it away. You just move it away from the horizontal bar. So what we're doing is we're adding and we're subtracting. Adding and subtracting. It's a very subtle difference, but pay attention to the beads, right? The beads of the position tells you what they're doing. So we have 6 on the abacus. 6 looks like 1 bead on top, 1 bead on bottom, right? But when we're trying to add 3 on the abacus, how do you add 6 to that? Again, 1 bead on top, 1 bead on bottom, and my final answer is 9. So when we're moving the beads, we're only moving the beads as the item, right? We're not moving specific beads. Like if this is 7, it's 1 bead on top, 2 beads on bottom. If I already have 2 on the abacus, then how do I add 7? Again, it's 1 bead on top, 2 beads on the bottom, and you bring it together. So my final answer is 9. Hello, everybody. Hello. Thank you so much for joining. Thank you so much for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
So we have 8 on the abacus. 8 is 1 bead on top, 3 beads on the bottom, and that's what 8 is. But if I have 1 on the abacus already and I want to add the 8, what do? Again, it is 1 bead on top and 3 beads on the bottom, and you add it together. Thank you, Machiavelli, for sharing the live. So this is what we call 9. Right? Does that make sense? Thank you, everybody, for joining. Thank you, everybody, joining. And you notice if we need to subtract, it's the same way. So if I have 9 on the abacus, I want to take away 6. Take away 6 is 1 bead on top, 1 bead on bottom, and you push it away like that. Please follow, like, and share. Thank you so much, Machiavelli. Thank you so much for the reminder. Thank you, everybody, for showing up. Thank you for spending some time with me. And if you want to check in over at the orange heart me right around my forehead, go ahead and click on that to be a part of my community. Thank you so much, everybody. Thank you so much. So when we're looking, right, we have 3 on the abacus, and we could do it again. So if I have 7 on the abacus, no. If I have 9 on the abacus, I want to take away 7. To take away the 7 is what? Take away 1. Take away the top bead, take away the 2 bottom beads, and you push it apart like that. So my final answer is 2. That's it. Thank you, everybody, for joining. So we have 8. Again, 8 is just 1 bead on top, 3 beads on the bottom. If I have 9 on the abacus, I want to take away 8. To take away 8, it's 1 bead on top, 3 bead on bottom, and then my final answer is 1. There we go. How is it going? We're all right? Make sense? Anybody have questions? Anybody have questions?
Bueller? 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 Bueller?
Hello! Jess. Thank you, Shadow. Thank you, Shadow. I do try my best to continue on and tweak as I go. Thank you so much, Shadow. Oh, Jess. So, in mainstream math, in public schools, the kids are supposed to memorize how to make a 9. I'm like, why are we memorizing how to make a 9? In Abacus world, we don't need to, right? We have 1 on the abacus, we want to add 8. We have a top bead on the with the top bead and the 3 bottom beads, you add the 8. Right? So notice that I don't need to memorize how to make a 9 because it's right there. If I have 2 on the abacus, I want to add 7. To add the 7, it's 1 bead on top, 2 beads on the bottom, I add the 7. And there we go. Easy. Simple. I don't know why we need to do this. What's the match equal to what? I don't know. So we have 3 on the abacus, and I want to add the 6. Guess what? To add the 6 is 1 bead on top, 1 bead on the bottom. You bring it together. So my final answer is 9. So we actually don't need to memorize it. In Abacus world, we don't need to memorize how to make a 9. So we have 4 on the bottom, and then 5 on top, and then my final answer is 9. There we go. So, for those of you that are interested, thank you so much for joining. Thank you so much for joining. My name is Lynette. We are reading the Abacus. After we read the Abacus, we know how to add, subtract, multiply, and divide. Thank you, everybody, for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Never Again, followed. Thank you so much, Never Again. That's a very funny screen name. All right, so a new goal, 30K. Oh, yeah, thank you, Machiavelli. Thank you. I would appreciate that. We're going to continue on for adding and subtracting. So the first thing we're going to do is understand how to make a 5. That is what we're trying to do. Why? Because we already know what happens when there's not enough. Oh. Okay, so, or do we want to go into, or, oh, where's my poll? Here's a poll. Let me see if I can make a poll. Why did my poll? Hold on. Nope. Trying to look for a poll. Co-host? Nope. Where is this? There it is. So what if I did this? Okay. So, what would you guys like to do? Do you want to do that? Ah, okay. So, there is a poll. There's a little blue thing at the top. So, This is a 2-digit maze. I can't see anything. This is a 2-digit maze. It means that we're going to focus on the tens and the ones, and then this is the maze. This is a maze that we go through, and then we have the answers and we follow the answers to go to the next box. We do have a 3-digit maze. A 3-digit maze just means that we're going to be going to the hundreds, the tens, and the ones. If you're interested in that, we can go through and figure out what these numbers are, and then it goes through as a maze. And then we have our next one. Our last one is a 4-digit maze. A 4-digit maze is the thousands, the hundreds, the tens, and the ones. That's what that is. And so, again, it's a 4-digit. And we would figure out what these numbers are, and then we'd find our path. Which ones would you like to go through? Celebrate my birthday? Ooh, Machiavelli, this is for you. Oh, wait, hold on. Hold on. Where is my... Hold, please. Oh, I lost it. Oh, here it is. Here it is. Here we go. Here we go. Machiavelli, this is for you. Or this one. I don't know if anybody remembers Stevie Wonder. Alright. I think I've lost it. Alright. Whoa. So, you don't know? If you don't know Stevie, haha, Stevie Wonder. Yeah, right? Stevie Wonder. Okay, here we go. Thank you. Yes, I remember Stevie Wonder. Oh, snap. Yeah. You're welcome. You're welcome. I was like, I should get some birthday sound bites. So those are for you guys. All right. So we have a 3-digit number coming through, and we have a 4-digit number. Okay, that'd be good. We can start practicing on some 3-digit and 4-digit stuff. He's still alive? Really? How old is he? He's like 80, 90 now? Woo! He's living a very healthy life if he's that old. And awesome. My goodness, that's crazy. That's crazy. Okay, so the winner is, right now we're going to do a 3-digit. Thank you, Jess, and thank you, Jen. Thank you, Frankie. Thank you so much for joining. We will go into how about we do the 3-digit in a little bit. We'll do a 3-digit. We'll do a 4-digit. You'll see how easy it is. So here is a 4-digit number. This is the thousands, the tens, the hundreds, the tens, and the ones. So he's 75. That's it? He's only 75? Wow, he was so young when he started. All right, we have our number. That's crazy. That's crazy. I would have thought he was a lot older. 75 is still really young. 75 is young. Thank you so much for the rose, Jess. Thank you so much for the rose. I do appreciate it. Ah, thank you so much. Thank you so much, Jess. I appreciate that. 75 though. Whew. Okay, thank you so much for joining. So we're going to have our next number. We have our tens. Nope. We have our ones. We have our tens. We have our hundreds, and we have our thousands. What number do you think that is? You got it. Ah, thank you so much. Thank you so much, Jess. I do appreciate that. What number do we think that is? It is not 75. I'll tell you that. For those of you... Oh, excuse me. What do we have? I need to find I lost it. Oh, here it is. Yeah, thank you. It is 7,000. Yes, it is 7,760 with a 0 at the end. Yes, you remember the 0 at the end, right? Because we want to keep the zeros on our paycheck. So how does this look? Well, the top beat is a value of 5. The bottom beat's a value of 1. So when we put it together, this is actually 6. We have the top beat is a value of 5. The bottom beat's a value of 2. And together, this is actually 7. So we have, again, 7. And when we're looking, we have our ones, our tens, our hundreds, and our thousands. Thank you, Jen. Thank you, Jen. So this is 7,760. And then we have our next number. We have our thousands, hundreds, tens, and one. What number do we think? Hello, colloquial rubbish. Thank you, man. I love learning about the abacus. Let's go. I love drinking water too. Likewise, likewise. Thank you so much for the reminder. Hello, Dimples. Hello, Dimples. It is so late for you. Thank you, Jen. It is 6,245. Thank you, Frankie. See, Frankie? Easy, right? Hello, Dimples. So we have 6,245. And then we have our next number. What number do we think this is? We have our thousands, our hundreds, our tens, and our ones. Every number is represented on each column. So there's always going to be a 0 to 9, 0 to 9, 0 to 9, 0 to 9, each of them. Does the abacus come with the books? You can purchase an option with the abacus with the books, yes. So the mazes come with an abacus, yep. All the beginning books have the options to buy an abacus. But later on, there is no option because I would assume that you already have your own abacus. Thank you. Thank you, Frankie. Yes, thank you, Jen. Thank you, Machiavelli. Yes, it is 8,733. 8. The top beat is a value of 5. The bottom beat's a value of 3. So, the top beat is a value of 5. The bottom beat's a value of 1. There's 3 ones together, so this makes 3. So 5 plus 3 is equal to 8. 5 plus 2 is equal to 7, and here is only 3. The top beat is not touching this horizontal bar, so it's not being counted. And then, thank you so much for the share. Thank you, Baby Birds and Shenanigans, for the share as well. So then the next one is also 3. 1, 1, 1. 3 ones gets to be 3. So the answer is 8,733. There we go. Set 8,733, and our next number is this. What number do we think this is? So we have our we have our thousands, our tens, our thousands, our hundreds, our tens, and our ones. What number do we think that is? Thank you, Frankie. It is 9,283. Thank you, because the top beat is a value of 5 plus 4 is equal to 9. We have 2, 1, 2. Because the top is not touching this horizontal bar, this is only 2, and then this is 8. The top beat is a value of 5, and the bottom beat, 1, 1, 1, is 3. 5 plus 3 is 1, and then we have it again. Without the 5, this is only 3. So the answer is 9,283. Thank you, Jen. Thank you, Machiavelli. Thank you, Frankie. So we have 9,283, and then it takes us to this number right here. This is so easy. I hope this makes sense to you. We have our thousands, our tens, and our ones. Thousands, hundreds, tens, and ones. Welcome, everybody. Welcome. Please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
It is 6,101. 6,333 looks like 6,333. 6,333. That's what that would look like. However, our answer is 6,111. That's what that is. And then we have our next number over here. So What number do we have here? We have our thousands, our tens, our hundreds, our tens, and our ones. What number do we think that is? Thank you, Edwin. Thank you, Edwin, for the follow. Thank you so much for the follow. So when we're looking, right, we have 1,419. Thank you. Yes, you're absolutely right. We have our ones, tens, hundreds, and thousands. So we had 1,000. Don't forget, we have a comma right here. This is my thousands, and that's my comma comma indicator, my label. So my thousands, hundreds, tens, and ones. So we have 9. The top beat is a value of 5. The bottom beat is a value of 1. 1, 1, 1, 1. There's 4 of them. So this is actually 4 plus 5 is equal to 9. There's a 1 here, there's a 4 here, and there's a 1 here. None of the top bead is being, these top beads are not touching, so they're not being counted. That's why this is 1, 4, 1, 9, because the top bead is touching, so then it's counted. So we have 1,419, and then we take up to this number over here. What number do we think this is? We have our thousands, our hundreds, our tens, and our ones. What number do we think this is? Thank you everybody for joining. Thank you everybody for joining. Thank you so much for tapping. Thank you so much for tapping. Yes, thank you, Frankie. Thank you, Jen. It is 9,239. So we have, again, the 5 is the top bead. 4, 5 plus 4. Thank you, Edwin. It is 9,239. Thank you, Machiavelli. Thank you for the follow, Frankie. So we have 5 is the top beat, 4 ones, 1, 1, 1, 1. This is 4 ones. This is 4 plus 5 is equal to 9. We have 2, we have 3, 1, 2, 3. We have 9 again. 5 plus 4 is equal to 9. Well done, everybody. Well done. So we have our next number. And then after this, we'll go into some adding and subtracting. So we have our hundreds, thousands, our hundreds, our tens, and our ones. What number do we think that is? Thank you, Jen. 4,245. Yes, yes, yes. Thank you, everybody. Thank you, Edwin. Thank you, Frankie. Yes, 4,245. And that's what that number is. And we're going to take over this one over here. So what number do we think this is? We have our thousands, our hundreds, our tens, and our ones. What number do we think that is? Thank you, everybody, for joining. Please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
Thank you, Edwin. Thank you, Frankie. Thank you, Jen. Yes, thank you, Machiavelli, for the reminder. Thank you, everybody, for our 22,000 likes. This is really awesome. Thank you so much. So our answer is 5,181. Well done. Well done. 5,181. And then that will take us to this number over here. And we are going to go, it's open now. Jen, did you get your package? So we have our number, we have our thousands, we have our hundreds, we have our tens, and we have our ones. Yeah, I sent it out. I sent out your package the next day. So you should be getting it soon. Yeah. I just got a new order of colorful Abacus, and I'm still waiting for more shipment of books. Thank you. Yes, thank you. Love it. Oh, good. And you saw it was wrapped. I'm hoping it was wrapped because sometimes the husband doesn't wrap it, but I wrap it. I try to wrap all of my Abacus. Into little packages. Oh, yes, thank you, Edwin. It is 3,499. Yes, thank you. Because we have the top beat is a value of 5, right? Plus the 4, 5 plus 4. So this is 9. This is 9. So nicely. I loved it. Yeah, see, that's what I said. I told, so my husband's like, you don't need to wrap it. And I'm like, but it's pretty when it's wrapped. You know, it felt like Christmas. Yes, I thought so too. I liked it. But it does take time, but it's nice. It's a little nice thing. And then, yes, 3,000. So we have 3, 1, 2, 3. We have 400, 1, 2, 3, 4. And then we have 9 and then 9. Thank you, Edwin. Yes, thank you, Jess, for the rose. Thank you so much for the rose. Yeah. Oh, hello, board. It is 9. Yes, thank you. 9:46. It shows you care. Ah, thank you. I appreciate that. So we have our next number. We have our ones. I'm sorry. We have our ones, our tens, our hundreds, and our thousands. What number do we have? What's wrong, board? How's school? School's going? Thank you. Thank you, Jen. 4,457. Yes, thank you. Thank you, Edwin. Thank you, Edwin. Yes, well done. I just did algebra 11, chemistry, and English. Oh, well done. Did it take you 4 hours? 4,402. And then we're in our final number. And then we're going to go into some adding and subtracting. So we have our thousands, we have our hundreds, we have our tens, and we have our ones. 2 hours? It took you 2 hours? I need to buy this. Thank you, Edwin. Chemistry alone took me 2 hours. Thank you, Jen. It is 8,573. Well done. Look at that. That's awesome. We're almost there. Almost at 30,000. Okay. Are we ready to learn how to add? What happens when there's not enough beads? Now we're going to get into something called formula. A formula is when we start to understand how to move this. Thank you everybody for joining. Thank you everybody for joining. What we're doing is we're learning how to read the abacus. Hello, is it Al or AI? Hello, Al. You're still confused? Or did you just get here? Can't still be confused if you just got here. There's no way that you can still be confused. I can't count on my dad. William. But I can count next to the abacus. You're so funny, William. And algebra 2 in English took me 2+ hours. Good. Keeps you off from doom scrolling, board. I'm so happy. Good. You should get out there. You should do your work and not doom scroll. Stop doom scrolling. You were doom scrolling so much before school. Hello, Cookie. Welcome, Cookie. How's it going? Al, did that make sense? We have 1, 2, 3, 4. The top bead is always going to be a value of 5, so that's what 5 looks like. We have 6, 5 plus 1, right? 5 plus 1 is 6. This is 5, and then we add the 1. We have 2, 1, 2, add the 5. This is now 7. We have 3, 1, 2, 3, add the 5. We have 8. We have 4, 1, 2, 3, 4, add the 5. And then we have 9. How am I doing? I'm doing pretty well. I might get a coughing fit, but the allergies are subsided. No, I'm sleeping, and I'm not fully done, but I'm sleeping to understand more. Good, board. You should go to sleep. So what's 10? 10 is actually 1 and a 0. That's what it is. Oh, thank you, Cookie. Thank you so much. Thank you for tapping, everybody. Thank you so much for tapping. I do appreciate it. But good, board. Thank you, Machiavelli. Welcome, everybody. Please follow, share, Lynn. Thank you so much, Lynette's an awesome teacher. Thank you. Thank you. Yeah, the allergies were coming in because of the Santa Ana winds. Hi, board. I agree. Get some sleep. Yes, no more doom scrolling. But that was the craziest thing. I remember when I took physics and I was like having some problems, I would actually go to sleep, and during the twilight of that sleeping and stuff, I would actually able to figure out a few things. So get some rest. Your brain will need it. With all the studying and creating wrinkles in your brain, it'll be really good. So good luck, board. I hope. Yeah, you can't be on my stream because I don't think I'm going to put you to sleep. All right, we're going to do some math. We've already talked about how to we already talked about the preschool book. Now we're going to start talking about how to make a 5. How to make a 5 is one of those pillars that we need to understand. Oh, right. Board, if you're taking a shower.
Step 4, shower. And always be sure to keep the soap out of your eye.
Make sure you keep the soap out of your eyes, board. So this is the book. This is how to make a 5. How to make a 5 means what? We're trying to understand 4 plus 1 is equal to 5. We have 1 plus 4 is equal to 5. 3 plus 2, 2 plus 3, right? These are all the things that we want to do. So this is what we're going to do is we're going to learn to make a 5. The reason why is because we have this 5 that we want to utilize. Now, when does this happen? It happens when we want to add, let's say, 4. So we have the abacus, right? We have 4 on the abacus. We have 4. We're going to do 2 ways. I have my pennies, and I have 1, 2, 3, 4 on the abacus. 1, 2, 3, 4. But if I don't have enough to add another 4, what I want to do, I want to do this, but this is not adding 4. This is making it 44. Right? So what we're trying to do is we're trying to add 4 to the ones place. That's what we're trying to do. We're trying to add 4 to the ones place. To add 4 to the ones place, you're going to have to utilize this 5. This 5 is over here, right? This 5 is too much. But so if it's too much, guess what? I have to take away the 1. So what we're doing is we're making change. So my final answer is 8. 5, 6, 7, 8. I can do it again with my abacus. I can add the 5 and minus the 1. And my final answer is 8. That's a little confusing. I know. Okay, let's try a different way. Let's try these little cubey thingies. So these little cubey thingies, I have 4 of them. 1, 2, 3, 4. I want to add another 4. So I'm going to add another 4. I'm going to add another 4. That's what I'm going to do. So when I add another 4, right, that's what I do. But guess what? There's no more room on the abacus to add the 4. So what do I have to do? I have to make a 5. 4, I have to round it up. 4 plus 1 is equal to 5. I have the perfect shirt to wear tomorrow because of what's happening. Oh, yeah. Yeah. We got to make a 1. We got to get the 1 from somewhere. The 1 has to come from somewhere. The 1 has to come from the previous number. So we got to take away 1 from here. So we got to give it away. So we take away 1 from the previous number, and guess what? We're going to add it to the bottom number, and now I've made a 5. See? I've made a 5. So I add it to, and I make a 5. So my final answer is 8. 5, 6, 7, 8. Thank you, Alan. Hello, Alan. Funny board. Your shirt sounds very funny. It says, "You people." That's really funny. That's very on the point. Yeah, it's crazy what happened today. So we have our 3 on the abacus. We could do it again. If we have 3 on the abacus, I want to add 4. Now, guess what? If I have 4, there's not enough room to add the 4. Thank you, Jess, for the roses. Thank you so much for the roses. Thank you again for the reminder. Please, if for those of you that are just listening and watching, if you can tap your screen, I would really appreciate it. We're almost at 30,000 likes. That's pretty awesome. We're almost at 30,000 likes. So here we have 3 plus 4. Notice when we add the 4, there's not enough. So what are we going to do? Well, we got to round this up to a 5. To round this up to a 5, we need to add the 1. To add the 1, we got to get it from somewhere. If we get it from somewhere, we got to get it from a previous number. So we're going to give it away from here, right? And then we're going to add that, right? We can take this away and we're going to add it to our bottom number. Now I've made a 5. So my final answer is 7. 5, 6, 7. I have 5 plus 2 is 7. So just like drifting.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
Oh, that's interesting, board. Cars. Yeah. 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 Well, oh my God. Thank you, everybody, for the 30,000. Thank you, everybody, for the 30,000. Thank you so much. Well done, everybody. Well done. Hopefully we can get out to the FYP. Thank you, everybody, for the 30,000. So does that make sense? Well, let's see. We can actually scale it. We'll do it one more time, just for good measure. So we have 2 on the abacus, just for you guys that just want to make sure they make sense. So I have 2 on the abacus. I want to add the 4. To add the 4, right? I have 2 on the abacus. I want to add the 4. To add the 4, To add the 4, what do? I need to make the 4 a 5. Always go from the bottom one. The bottom number needs to make a 5. So the bottom one needs to make a 5. How do we make that 5? We need to do 4 plus 1 is equal to 5. Guess what? We got to take 1 from the 2. So I'm going to take 1 from the 2 and I'm going to add it to the bottom one. So now I've made a 5. So we take 1 from the answer. We take 1 from the 2, so it's plus the 5 minus the 2. That's the formula. And so my final answer is 6. So what we're doing is we're understanding how to do it. Guess what? We can actually scale it. So if I have my abacus, right, and I have my number, I have 1,357, right? And so when we're, thank you, Jess, for the Go Popular. I'm going to doom scroll for 10 minutes and then go to sleep. Bye. Bye, board. So our next number, right, we're going to add. It's a very big number, but we're going to add, and I'll show you how it's scalable. So our next number is this, 4,331. So we have 4,000. Remember, I had to add the 4. There's not enough. All I got to do is plus the 5 minus the 1. And then we're going to do it again. There's not enough room to add the 3, so we need to plus the 5 minus the 2. How do I know? Because when I add the 3, I need to make a 2. So I have to take away from the previous number. And then I do it again. You changed it for me. You found it. I didn't know if you were still here. So we have 3, 1, 2, 3, just need to add it. And then we do it again. So my final answer is, what's my final answer? I didn't know you were still here, Jen. I thought you would be asleep by now because you said you were tired. What number do we think? What number do we have right there? Yes, thank you. 5,688. Does that make sense? So what we did is we learned this concept of how to make a 4. We learned this concept how to make a 4 and how to make a 3, and we're now able to scale it. And that's what we did. That's what this is. Thank you, everybody, for joining. Thank you, everybody, for joining. Did that make sense? I hope that made sense. So for those of you that just joined, thank you, everybody, for joining. My name is Lynette. I've been teaching Abacus for about 20 years now. And what we can do is, thank you, N. That made sense? Okay, good. Some people get kind of grumpy about like learning new things, but that's what it is. And so what we're doing is just we're learning how to make a 5. And the Abacus way does it a little bit different than mainstream way. And so let's do a little review for those people that just joined. We're going to count on the Abacus. We have 1, 2, 3, 4, and then 5. I did leave, but you showed up on my FYP. So this is 5. This is always going to be a 5. The top B will always be a value of 5, and then we have 6. We have 5 plus 1 is 6, and then we have 7. There's 2, and then you add the 5, it is now 7. We have 3, 1, 2, 3, add the 5, now we have 8. We have 4, 1, 2, 3, 4, add the 5, and then we have 9. Bye. I'm mathed out anyways. See you later, board. I'll see you later. Thanks for dropping by, and thank you for telling me what the time is. It is 10 o'clock. It is 10 o'clock. Do you know where your children are? It is 10 o'clock. Thank you, board, so much for dropping by. Okay, so does that make sense? So then you might be wondering, what's 10? Well, 10 is actually a 1 and a 0. A 1 and a 0. So that's where our place values come in. Every column on the abacus has a place value. We have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. Oh, so we were actually doing this one right here. I have a bunch of books available in my TikTok shop. We were actually working with the How to Make a 5. This one was meant for children. I do have adults that did purchase this for themselves because they want to be able to learn how to use the abacus. And when you look at it, and here's a little flip through of the book. We talk about how to make a 5, make a 4, make a 3, make a 2, and make a 1, right? If we want to add the 1, how do we do it? If we want to add the 2, how do we do it? That's what this is. And then I give you mazes. I give you color by number. There's word problems and the hidden words. I have color by number and more mazes, and then I have tic-tac-toe. After that, thank you so much for the follow. After that, what else do I have? I think that's it. I think I have color by number. Oh, connect the boxes. That's what it is. Connect the boxes. So you start from where? You start from here. Yeah, you start from here, and then you have to add this to make the answer. You take away that to get the answer. So that's what connect the boxes are. Thank you, Rev, for the follow. Thank you, Beauty and Me too, for the follow. So the idea here was to get the kids engaged with learning how to do math, as well as working through puzzles and so forth. The answers are in the back of the book, and I have that. There we go. Thank you so much for the likes, everybody. Thank you so much for the likes. We're at 34,000. 34,000. This is great. So we have our number. Yep. Oh, yeah. So this is it. Thank you, everybody, for joining. This is what we're doing. For those of you that just joined, thank you so much for joining. My name is Lynette, and we are here to learn how to read the abacus. Here we go. All right. So we'll do it one more time. Here we go. Hurry up. Sorry. So, if I choose this one to be my ones place, the reason why is because I have a label. That's a dot right here. This dot tells me it's the ones place. There's another dot here. This tells me it's the thousands place. So when I match it up, we'll do 3,456. That's what that is. And then we could take it one more step. We could do 73,000, right? 73,456.25. So notice the point, right, is our decimals. Our decimals are right here. So it'll be 20 and then 5. Hello, everybody. Thank you so much for joining. Thank you so much for joining. Okay, so what are we doing? Oh, we're going to continue on. How to make a 10. How to make a 10? We're going to know how to make a 10. The interesting about this is that once we know how to make a 5, then the concept of how to make a 10 is very similar. How to make a 10. So if I have my question, which is going to be, let's do 8. 8 is a nice number, and we want to round it up to 10. So when we're looking, we know that 8 plus 2 is equal to 10. 8 plus 2 is equal to 10. Well, how is that going to work on the abacus? It's the same thing. The concept is still the same, but we have a different way. So we have 9 on the abacus, right? If I have 9 on the abacus, there we go. Sorry, excuse me. So we have 9 on the abacus. 1, 2, 3, 4. There we go. And then we have 8. So notice we have 8, right? And we want to make, so notice in abacus world, we always go from top down. We always go from 9 to 8, right? We don't go, what we want to do is we want to make the 8 a 10. How do we do that? Well, we know that we need to get 2 to make it, to add to it the 8 to make it 10. So the 2 has to come from somewhere. The 2 has to come from the 9. So we got to give away 9. We got to give away 2, right? So we give away 2 from the 9. We take that away. Guess what? We can take this and we can add it to our 8. So now we regrouped and we made a 10. So we regrouped and made a 10. So my final answer is 17. So what we're doing is we're doing exactly the same as what we learned with the 5, and now we could do it again with the 10s. That's what we're doing. We're regrouping, and then this will carry over, right, to the next one. So we could do it again with the 7. So I have 7 on the abacus, right? 7 on the abacus, like that. I have 8 that I want to add. But guess what? We don't have enough room to add the 8, right? There's not enough room to add the 8. But what we can do is we can carry over and we can make it 10. To do that, we have to add the 2. We have to take away the 2 from the 7. So take away the 2 from the 7 and then add it to the 8. And now I've made a 10. So my final answer is 15. How are we doing? Does that make sense? Thank you so much for liking the live, everybody. Thank you so much for liking the live. That's really nice. Thank you so much, everybody. I do appreciate it. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
How are we doing? Does that make sense? So what we just did is we just learned how to make a 10. Welcome, everybody. Welcome. Thank you so much. Please like and share and follow so it can reach to more people. Thank you, Machiavelli, for the reminder. I do appreciate it. And tap your screens. Thank you, Jess, for the reminder. So thank you, everybody, for joining. Thank you, everybody, for joining. We're almost at 40,000. How are we doing? Anybody have any specific questions for the Abacus? So thank you so much for joining. Thank you for looking at some of the products in my TikTok shop. I have all these books available. I also have the Abacus available. I don't have the bricks available. These are my own bricks. But I'm thinking about trying to figure out how to sell it with the colors, because I do like it with the colors. And then I do have all these books. So this book is specific for how to make a 10. When we're looking, thank you, Cookie, for sharing my live. So what we're doing is we're learning how to make a 10. And notice that we start from 9, and then we go to 10, 8, 7, I'm sorry, not 10, 7, 8, 6, 5, 4, 3, 2, and 1. And then I give you activities. So here is the what I call it is spin the wheel. You take a paper clip and you spin the wheel wherever it falls, then you put it to the thing over here. And then we do the 4, how to make a 4, how to make a 2, or what happens when we add a 3, add a 2, and then add a 1. Thank you so much, everybody. And then after that, I give you a puzzle piece, answer the puzzles, find the puzzle numbers. I give you the hidden words and so forth. So these are all of the activities towards the end to strengthen and solidify the concept of what you just learned. And then we have the hidden words and more puzzles. I think I have more. Yep, I have mazes. And then I have color by number. I believe I have a color by number. Oh, I guess not. So there's answers in the back of the book. That's what that is. Okay, how are we doing? Thank you, everybody, for joining. Thank you, everybody, for joining. So that's my book. This is available in my shop. I didn't. It's this one right here. Yep. And so when we're looking, it comes with answers, and then that's the idea. I tried to make it themed. This one was asteroids. Not asteroids, space. That's what it is, space. And we could do it again. So we have 7 on the Abacus. Okay, well, let's see how this looks. So when we have 18 on the Abacus, we want to add 7. So what is it? We have 18 on the Abacus when we add the 7. Adding the 7 means what? Plus the 10 minus the 3. Take away the 3 from the previous number, and then we add the 10. So my final answer is 25. And then we could do it again with the 14. So when we do 14, right, we have 1 on the Abacus. We want to add the 7. I'm sorry, we have 14 on the Abacus. I want to add the 7. To add the 7, what do? We know to make a 10 out of the 7, we have to minus the 3. So we minus the 3 and then plus the 10. Because plussing the 10 means that we're going to carry over. That's what that means. Yep. So, how are we? Thank you, everybody, for joining. Thank you, everybody, for joining. For those of you that are interested, so 2, this is actually 21. 21 is anytime the beads are touching the horizontal bar, that's what's considered counted. So we have 20 and we have 1. That's what that is. So we have our 10s, that's a 10s, and then this is our 1s. There we go. Hello, everybody, hello. So we have our place values. We have our 1s, our 10s, hundreds, thousands, and then 10,000s. Cool? All right. We're going to do this one. All right. So let's go back a little bit and figure out another pixel art. So this one was picture A. Picture A. All right. That one needs to go over here. I have another one. I have like 2 more that I got to do. There's this one, and then we can double check this one. All right, let's do this one. Let's see what picture this is. All right, so what number do we think this is? Yeah, this is a 2-digit number. Oh, I'm going to use, oh, hey, I'm going to use this one. What number do you think this is? If I have this 2, right? I have these 2. What number do you think that is? Woo! Oh, I just dropped it. Hold, please. Oh, my gosh. Okay, what number do we think that is? Great job, everybody. Thank you so much, everybody. Thank you, D. It is 22. So we have 20 and then 2. Yep, thank you. So we're going to add my 22. All right, what's our next number? Our next number is our 10s and our 1s. What number do we think that is? Thank you, D, for the follow. What number? Is it 200? It is not 200. It is 75. 200 would look like this. We have 200, but this is actually 75. 75 is the top beat is a value of 5, and the bottom beat's a value of 2. So we have 75, and then we have our next number. So what we're trying to do is we're trying to figure out what this pixel art is. Another pixel art that's kind of random. So we have our next number. We have our 10s and we have our 1s. What number do you think that is? Let me move my stuff. What number do you think that is? That one right here. So we have our 10s, right? And then we have our 1s. The top beat is a value of 5, and the bottom beat is a value of 3. When we're looking, thank you, Jen, it is 80. It is 80. Well done. And then we have our next number. So we have our 10s. So when we're looking, we have our 1s and our 10s. 1s, 10s, hundreds, thousands, and then 10,000s. And then we have that number. We have our 10s, and then we have our 1s. What number do we think that is? Mm. 71. Thank you, Machiavelli. That's what I got so far. We only got 4. 71. So now we have our next number. We have our 10s and our 1s. What number do you think that is? $71. Thank you, Jen. What number do we think that is? Thank you, Machiavelli. It is 51. Thank you. Yes, it is 51. 51. And then, thank you, Jen. So 51 is over here? I don't know. It's too early to tell. We have our 10s and we have our 1s. What number do we think this is? 50. Thank you. Got it? 57. Thank you. 50 and then 7. There you go. 57. Thank you. Can you do a math equation for 9 divided by 11? What would that, no? I would have to think about it. You want to do a division question that's like 9 divided by 57. There we go. Philippe. I'm late again. Hello, Redux. You're okay. We're looking at this new pixel art that I have created, and I have to figure out what this picture is. So we have our 10s and our 1s. I still haven't learned. What have you not learned? You learned. You know what this is. We have our 10s and we have our 1s. What number do we think that is? $54. Thank you. Thank you, Jen. Thank you, D. I don't know. 50? Almost. So the 4 is right here. Yep. We have to do 54. 50 would look like that. That's what 50 would look like. So our next number is that. What is our next number? We have 80. I think I'm getting the hang of it. Oh, good, D. I'm trying to understand. Hello, L. Have a good night, Thank you, Machiavelli, so much. Thank you. Have a great day. Thank you. Keep up the great work. Thank you. See you in my next live. Thank you. And you know what? Hopefully you'll get some bubble gum.
I have come here to chew bubblegum and kick ass. And I'm all out of bubblegum.
Good night, Machiavelli. Good night.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
So this is 54. This is 82. Thank you, Redux. Thank you, Jen. Thank you, D. Yes. And then we have our next number. 82. So we have our next number. We have this one and then that one. What number do we think that is? 72. It is 72. Thank you. 72. Because the top beat is a value of 5 and the two bottom beats is a value of 1. And 1, 1. So 5 plus 2 is equal to 7. And then this is 2. Because the 5 is not touching the horizontal bar, then that means that this is just 2. So we have our next number, right? That. What number do you think that is? Yes, thank you, Jen. Yes, it is 76. 76. So, I don't know. Does it look like a boat? Thank you, Noah. Thank you, L. Right, L? It's easy. Getting easy? So, what we're trying to do is we're trying to figure out what this pixel art is that I've created so long ago. We have our next number. What number? 80. Thank you. 88. Thank you, Noah. Hello, 300. So if I have 9 on the abacus, oh, that's not 9. If I have 9 on the abacus and I want to add the 10, that's what I would do. All I would have to do is add the 10. Does it look like a boat? I don't know. I don't know what it looks like. All right. What's our next number? That. Thank you, Jen. Thank you, Noah. Thank you, D. Yes. Looks like a right-handed thumb. Oh, yeah, I see that. I see that. Thank you, Noah. It is 69. Yeah, it does look like it. Like something like this. Or, I don't know. Yes, thank you. It is 69. So we have 60, and then we have 9. Thank you. 69. So what's our next number? We have our 10s, and we have our 1s. What number do we think that is? Thank you, Jen. Thank you, D. Yes, 31. 31. And then it's coming. I'm not sure. So we have our next number. 55? It's not 55. Because the 5 is not down. This would be what 55 looks like. Thank you, Jen. It is 40. It is 1. Yeah. Yeah, 55 looks like that. That's what 55 would look like. 41. All right. Oh, I see. You did this one here. That's what 55 is. Yep, you're right. You're right. You're right. So 55. So this is 55. And then we have our next number. Yeah. Why? It's easy, but why so many pegs? I'm not sure what they're called. Oh, I thought. Oh, yeah. No, I see that D. I see that D. Thank you. Why so many columns? Because every column is a representation of a place value. So when we're looking, hold on. When we're looking, we have. There we go. So L. When we're looking, we have our 1s, our 10s, hundreds, thousands, and 10,000s. That's why. 83. Yes. Like, thank you, little pizza man. It is 83. Thank you, Jen. Thank you, D. It is 83. Maybe a rabbit? I don't know. I don't know. 83. I think that's too complicated if it was a rabbit. So what's our next number? We have our tens and we have our ones. So yeah, they're not pegs, they're called columns. Thank you, user, for the follow. Thank you, user 0970. Thank you, it's 23. 23. 23. What's our next one right here? Thank you. Can you be my tutor? Yes, 23 is my favorite number. Oh yes, I see that, Cherry. Sure, sure. If you wanna DM me, we can talk about Abacus. But I don't do anything else. I only do Abacus. I don't do anything else. I just know how to add, subtract, multiply, and divide. What's our next number? We have 87. Thank you. I don't know. 87. This is kind of hard. Like trying to figure out what the picture is. Okay, we have that number and then that number. Maybe it looks like a car? I don't know. Maybe a shoe or a sock? Maybe. What number do we have there? 58? It is not. It is 50. No, it's 78. We have the top beat is a value of 5. We have the two bottom beats, so it's 70. And then we have 8. 5, 6, 7, 8. A shoe or a sock? Oh, I could see yeah, maybe like a really big foot. Ah, oh, my goodness. 78. So I guess I know what I'm going to be putting into the adult one. What made you wear glasses? The fact I can't see? So that's really funny. They're not fake. I don't want to pretend to look smart, and I am not smart, but I do it so I can see. Thank you, Seeking Susan. Yes, thank you. It is 44. Yes, that's what it looks like. So every time we figure out a number, I color in a cube. I color in a square. So we have our next number. Thank you, Silk, for the breakup. The little break. Let's see. We have our number, right? And then that. All right. What are we doing? 73. Yes, thank you. 73. Oh, 73. 73. There we go. 73. I don't know. Maybe a shoe? Yeah? Okay. What's our next number? This one over here. So guess what? I probably put this one in my next adult book. That one. All right. A rollerblade? I don't know. The top beads are 5. Yes, the top bead is a value of 5 and the lower bead's a value of 1. Yes, yes, you're absolutely right. Absolutely right. What's up? Hello. The kid. Oh, yeah, right? So strange. Yeah. 79. Maybe rollerblades? Like a roller skate? I don't know. What's our next number? Yeah. 77. Thank you. Thank you. It is 77. 77. Maybe a roller skate? Wow. I can't see anything. Yeah, I thought you'd explain. What, with the little kid spazzing doing abacus? That's just the way they do abacus. So, it's a train? You think so? All right, what's our next number? We have our tens and we have our ones. We have 50. Maybe it's a train? I like the umbrella, the previous one. 58? Yes, it is. Made you look. Yes, it is 58. So we have 5 and we have 8. We have 5 and we have 8. Yeah, I don't know. I don't know. It's been so long. I think I did that like 4 years ago and I was like, I should dig out some of the old stuff. Oops. 56. Thank you. Thank you, Pam. Oh, hello, Pam. Thank you, Pam. Welcome back. I feel smart doing this. You do? Thank you. I appreciate that. I appreciate that. It is 56. Thank you. Thank you, Pam. Hello, hello, hello. Hello. So we have our next number. There we go. I don't know. What number do we have? Yes, thank you, D. It is 34. Nope. The top beat is not touching the horizontal bar, so it's not being counted, Pam. So when we're looking, that would be 80, and then that would be 9. But we'd have the 2 top beads is not touching, so that's not considered counted. So we have our next number. We have that one. Yes, thank you. Thank you. Thank you, Jess. Please for those of you that are still here, if you guys can tap out my screen, that'd be fantastic. I think it's a roller skate. I just joined. What is this? I'm so lost. Hello, Dookie. 24. It is 24. Thank you. It is 20. It is 4. 1, 1, right? 2 ones. That's a 20. And then this is 4. 1, 1, 1, 1. These are all 4s. So what number do you think this is? That should be easy. Thank you. It is 21. 21. I think it's supposed to be a roller skate. What do you think? So we have our last number. We have our 10s and our 1s. Yep. The age I am in my head. Yes, it is 74. So that's what it is. 74. So I guess I'm missing something. What do you think it is? It's my pixel art. There's a few things I need to fix. I feel like my brain is getting bigger. Aha, muted mins. Yeah, right? Skateboard? Is it a car? It looks like a car. Okay, looks like a car. What else? An upside down gun. I can't do guns. Bingo! Yeah, no, guns is not good. Guns is not good. Because it'd be for kids. So, yeah. I like that. Upside down. I like the car or a roller skate. I think it's a car or a roller skate. Car, roller skate. Thank you, everybody. Yeah, we did the other one. So we did this one earlier today, and that's what it looks like. So I got to clean that up a little bit and make it a more of a... What do you think this is? A roller skate? Okay. Okay. Are the top... Yes, the top beads are... What are the top blue beads? The value of the blue beads is a value of 5. You think it's umbrella? It's a tree? Okay. Tree, umbrella. Thank you, everybody, for helping me. I don't know. Oh, sorry. I don't know. Is it a toadstool? Oh, that's funny. Toadstool. Am I a teacher? I can kind of see you as one. I'm an abacus teacher. I teach abacus. So yes, so the top beat would always be a value of 5. So here we go. Here we go. Yeah, I was just making some activities and I was like, I don't even know what these pictures are. So where are we? We are over here. We're over here. No? I need to find my papers. I've lost it. Hold please. I'm still trying to find some papers. Maybe it's over here. Oh, here it is. Okay, so let's continue on how to read the abacus. So we have our number. Notice I have my ones over here, I have my three over here. My ones over here, my thousands are over here. So when I look, just like the comma in the thousands, like this comma right here, it helps me. I can only stay a minute, but now that I'm following. Oh, that's great. So we're just going to continue on how to read the abacus, and then we're going to do some adding and subtracting. So we have 3,456. That's what that would look like. And then when you look, it's kind of nice to have the comma because it's easier. I can find you. Oh, yeah. So then this is what it would look like. It's harder to see. That's why the labels will help, right? This is my ones, this is my thousands. And so we have this. We have 73,456.25. So notice the dot is right here. This is my decimal. The decimal happens after, right? After the dot, there will be the decimals. It will be my tenths and then my hundredths. So then, who was it that asked about the 5? Yes, Griffin. This is 5, right? The top beat is always going to be a value of 5. So let me help you count that.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So we're looking, this is actually 55,000. We have we have the 10,000s and the thousands. So it's 55,000, we have the hundreds, and then we have the tens and the ones. We have 555.55. And then we have, yep, makes sense. So then we can do a row of sixes. So we could do a whole row of sixes. Oh, no, there we go. A whole row of sixes. We can do a whole row of 9. And then we can even do a whole row of 10. I'm sorry, 9s. A whole row of 9s.
99 problems, but a ain't one. If you having girl problems, I feel bad for you, son. I got 99 problems, but a ain't one. Hit me.
So we have 99,999.99. So that's what that means. So every column has every number represented. And you only go up to 9 because this is a decimal system. So when we're looking, we can count 1, 2, 3, 4. When we have 5, the top is a value of 5, and then we have 6. 5 plus 1 is 6, and then we have 2 plus 5 is now 7. We have 3 plus 5 is 8. We have 4 plus 5 is 9. And then what happens is what's after 9? 9 is 10. 10 is a 1 and a 0. Thank you for the rose, Ips. So this is not 10. The reason why is because this is actually 55. What this is 10. Does that make sense? So when we're looking at the 1 and a 0. So we have 1 and 10s. 1s and 10s. We can do 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 is a 2 and a 0. There we go. Thank you so much for the rose. How are we doing? Does that make sense? Let's do it another way. Let's say it gets really confusing. It's still confusing. It's okay. Here we go. Let's talk about like tally marks. We have 1, 2 tally marks, right? 1, 2. We have 3 tally marks. 1, 2, 3. And then we have 4. 1, 2, 3, 4. We have 5. Thank you, Griffin, for the rose. We have 5. The 5 is like a slash, right? So that's what that would be. That would be 5. And then we have 6, a slash plus 1, right? 5 plus 1 is 6. And then we have 7. 5 plus 2 is 7. And then we have 8. 5 plus 3 is 8. And then we have 9. 5 plus 4 is 9. And then 10. Again, 10 is a 1 and a 0. There we go. How are we doing? Does that make sense? So for those of you that are interested, I do have the abacus available in my TikTok shop. What are you doing? There's one right here. Okay, cool. So thank you everybody for joining. How are we doing? Anybody have any specific questions? Do you think the Egyptians invented it? Probably. It was right around the Mesopotamia. So wherever Mesopotamia is where it was invented, from what I heard. And so it was probably about 2300 BCE. Yeah. And so, and then after a while, China came around and made their own version of an abacus. And then Japanese came around and made it more efficient. So the Chinese abacus, it looks with 2 beads on top and 5 beads on the bottom. This is a Chinese abacus, but notice it doesn't have the markings. And so thank you again for the rose. Thank you so much. Thank you, Griffin, and thank you, Ips, for the rose. So we have the Chinese abacus and the Japanese abacus. So the Chinese abacus is 1, 2, 3, 4, 5. And then we have 6. I'm sorry, this is 5. Because we have 5 here, we're going to trade it in to make this a 5. And then we have 6, 7, 8, 9, 10. So we have we have a 5 here. We're going to trade that into this top one. And then we trade it again to make this a 10. So that's what 10 is. On the abacus, on the Japanese abacus, it's very similar. We have 1, 2, 3, 4. Then there's 5. We have 6, 7, 8, 9, 10. And there you go. Thank you, 305, for the hand heart. Thank you so much for the hand heart. Yeah, there we go. There we go. Does it? Oh, I'm sorry. And the galaxy. That's crazy. Thank you so much for the galaxy. Thank you so much. I appreciate that. Does the one make it easier? Less formulas, I mean? Yes, yes. So this one would be less formulas for sure. What they do is they actually do some counting up, which is interesting. Thank you, Jess, for the roses. Thank you so much for the roses. Thank you. I appreciate that. Yeah. And so yeah, it is very interesting. But it's more counting up, and there's actually no formulas. I was talking to somebody that actually knows how to do the abacus, and they said that they don't use formulas. Yeah. Oh my gosh! Thank you so much, Ibs, for that's amazing. Thank you so much for the galaxies. Okay, so when we're looking, right? When we're looking, that's the difference. And notice that there is no markings over here, because I don't think they dealt with decimals, which is very interesting. They didn't have to deal with decimals, and I think that's the new invention is the new invention was the decimals, because we start talking about thank you, Pam, for the roses. The decimals, I think that's a newer invention, because in Mesopotamia and right when did we start doing decimals? So that's the other thing. Is all depending on how we do our math. Like the new additions, like understanding how to do algebra, geometry, chemistry, and all this. Not chemistry, calculus and pre-calc and all that. That's actually all modern math, which is very interesting. And so I'm not sure if they use the abacus to account for any of that, because the abacus is only for basic arithmetic, adding, subtracting, multiplying, and dividing. You could do exponents, but what's exponents? Exponents is really just multiplication plus multiplication. What's the other one? The other one is square roots, right? So, oh hey, oh Robert sent you. Oh, welcome. So precise measurement wasn't around during those times. I don't think so. When hello, Robert. I have some few people that you mentioned. Thank you so much for joining. Thank you everybody for joining. I don't think precise measurement, because remember, precise measurements was whatever you had on your fingers. That's how we get inches, and because it's all about body parts. What is it? Inches, yards, and all that stuff. Thank you, Jess, for the reminder. The whole gang's here. That's funny. But yeah, so measurements in itself. So what was the empirical formula? The empirical formula happened because it was like body parts. And so, yeah, it wasn't precise. Yeah, inches. Thank you, Jen. Inches, feet, and yards. You know, funny. My son was like actually having a math test, and he couldn't do the conversions of inches, yards, and miles. He was like, I don't know how many feet are in a mile, and I'm like, I don't know either. I grew up with the metric system, so it was easy for me to do the conversion, and it was just really funny. And so I don't know if you ever heard of the SNL. Was it Washington's? Was it Washington's Wish? Have you ever heard of this one? It was so funny. It's with Nate Bargatze. I forget. I think that's how you say his name. If you look it up, it was so funny. So funny. Washington's Dream, I think it was. Washington's Dream. It's an SNL skit. Oh, it was so funny. I watched it like 4 times. It's so funny. Thank you, Tiggles. Yeah, yeah. It is 5,280 feet in a mile, but we don't know how many yards there. We don't know how many yards are there in a mile. No one knows. I don't know if anybody saw that. So if you get a chance, look at Washington Dreams. It's an SNL skit. It's so funny, and it talks about the future. Times that by 3. You know what? Let's do that. Here we go. Hold on. So let's do it. We do 5280 times that by 3. So on the abacus, we're going to figure this out. We need to figure out what our place values. So we have 1, 2, 3, 4, 5, right? So we have 1, 2, 3, 4, 5. What we do in Abacus World is we do distributive property. So when we do distributive property, what are we going to do? We're going to do 3 times 5. So 3 times 5, what's 3 times 5? 3 times 5 is equal to 15. Add the 1, add the 5, right? And then we have what? 3 times 2 is equal to 6. 6, why would you divide by 3? Because Jen said times by 3. Hey, lady, how's it going? Wouldn't you divide by 3? No? Jen said to times it by 3. I don't know. Thank you, Pam. I started to get a yard. See? I don't know. You're like, school started. Oh, school started. Oh, that's great. So exciting that school started. Okay, but we're going to continue on with timesing because I'm starting the times. So because we do a 0, we have a 6, we want to do a 0, 6. Right? There's 3 feet per yard. Okay. It is what it is. So it's a 0 and it's a 6. So that's what we're going to do. We're going to add the 6. I don't know. And then we do our next number, right? 3 times 8 is equal to what? 3 times 8 is 24. Thank you. 24. Add the 2, add the 4. So apparently, thank you. Hello, Chris. My gosh, Chris. Good morning. So late for you. Thank you, Pam. Thank you, user. Yes. So our answer is, but it has nothing to do with the yards and the miles. Pam. Oh, thank you, Jen. So we have 15, comma, 840. I don't know why we did that. I don't know what unit it is. I know. I got to go to work at 5. Oh my God, you should be asleep, Chris. Go to sleep. Hello, Joseph. Welcome back, Joseph. Welcome back. Hello.
Gee, Ray, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
Thank you, Mitz. Thank you, Mitz, so much for the rose. Okay, if you divide by 3, you get the yards. Okay, so we're going to do division. Okay, let's do some division. I don't know if it's going to work. I got some proof. I just got done proofing papers. Oh my gosh. I don't know how this is going to work. Let's see. All right. So this would be a good practice for me. Now, because I'm trying to figure out how to explain it better. Abacus World does it a little differently. In Abacus World, what we do is we do the missing, what do they call it? He called it a quotient partial. So what we do is we actually try to figure out, we don't say how many times does 3 go into 5. What we say is 3 times what is equal to 5. So what we're trying to do is we're trying to understand this. Is this new division? No, it's not new division. It's actually, it will be clean. Actually, it is old division because it's been around since the 1600s. 1, 2, 3, 4. So we have 4 digits. Take away 1 is equal to 3. I don't even know what this number is. So maybe we should just go up here just in case. 1, 2, 3. So we put in our 5, our 2, our 8, and our 0. 3 times what is equal to 3 times 1, right? 3 times 1 is equal to 3. So if I put, because I can divide it, I need to skip this column. This column next to it. So I have to add my 1 here. All right. So what did I just do? Let me see if I can find some paper. Let me find paper. Okay. That's not going to work. We do 3, 5, 2, 8, 1. 1, 2, 3. 5, 2, 8, 0. So what did we do? We did 3 times 1 is equal to 3. Okay? Why? Because we have a 5 here. So we're going to take away the 5. We know what that is. So we add our 1 here. We add the 1 here. Right? Because this is our quotient. There's a lot of moving parts because I'm trying to figure out how to explain it better in mainstream math in Abacus. So when we're doing it, what do? We take away the 2. To take away the 2 is what? Minus the 3 is equal to minus the 5 plus the 2. So minus the 5 plus the 2. So then what is our next number? Our next number is 3 times what is equal to 2. Can you do it? No, you cannot do it. So what do? We got to bring in the second number. What's the second number? The second number is over here. 1, 2, and 2. Right? So this would be the second number. We're making it a 2. It wouldn't be 8, lady. It would be 7, right? Because it'd be 3 times 7 is equal to 21. So if we have 21 here, we got to take it away here. So we add the 7 here. That's what this is, right? This is my quotient. And then we take away 20, we take away 1. We take away 20, we take away 1. And then what do? We look at our number. We have 3 times what is equal to 1. Do you see that? That's 1. And then what do? Can we do this? No, there is no multiplication fact that says 3 times is equal to 1. You got to use it as a second number. The second number is over here. So we got to bring in the 8. So what is it? So it's 3 times 6 is equal to 18. So we have our quotient. Our quotient goes here. And then we have to take away 18. Take away 1, take away 8. So our final answer is that right? 760? 1,760 is the answer. Oh, thank you. Yeah. So I got to figure out a better way to explain this because I know a lot of people say it's a lot of back and forth, but it's also a different way of thinking. Abacus is a different way of thinking. We don't use, once you get the question, we don't use this anymore. I go straight to the abacus. But then people can't read the abacus. So that's the other thing. Yeah. So. Yeah, I seem to have forgot. Oh. Yeah. Is this new division? No, this is not new division. It's long division. It's just long division on the abacus. That's what this is. So, interesting. I don't know. I got to figure out a better way to explain it. I'm not there yet. I know how to explain multiplication, and I know how to explain. Addition and subtraction, but division is still a little bit kind of hairy. It seems like it's a little bit more advanced than most people can understand. So I think the biggest thing is to understand is what you have to know your multiplication facts before you understand the division facts. So thank you everybody for joining. Thank you everybody for joining. Welcome, welcome, welcome. Wow. So, how are we doing? Let's do a little review. Thank you so much for your patience. Let's do a little review on how to read the abacus. So we're counting on the abacus. All we got to do is what we're trying to do is we're trying to understand what the beads are on the abacus. An abacus just counts and visualizes your numbers. So we can count 1, 2, 3, 4. And then what happens is after 4, we have 5. The top bead will always be 5, and then we have 6. 5 plus 1 is 6, and then we have 7. 5 plus 2 is 7, and then we have 8. 5 plus 3 is 8, and then we have 9. 5 plus 4 is 9. When you look, right, you'll notice that this is actually a decimal system. We follow the decimal system, so it's not something that's different. It's not something that's foreign. It's just something that's different. So when we're looking, right, what's after 9 is 10. This is not 10. This is actually 55 because remember the top bead is a value of 5, the bottom bead is the value of 1. When we're looking for 10, 10 would actually just look like that. So yes, this is a decimal system with a 10 numerals. The 10 numerals is 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Thank you, Doug. Hello, Doug. Hello, Doug. Do you have some bubble gum?
I have come here to chew bubblegum and kick ass. And I'm all out of bubblegum.
No yawning. Oh my goodness. Oh my goodness. Thank you so much for the heart me. Thank you so much for the heart me. Welcome everybody. Welcome. Go ahead and check in over around with my orange heart me if you're interested to gain some engagement points. So thank you, Kylie. Did you not understand the words are coming out of my mouth?
Do you understand the words that are coming out of my mouth?
Do you understand the words that are coming out of my mouth?
Thank you, Jess, so much for the rose. Thank you for all of the roses. Thank you so much. Thank you, Doug, for tapping. Thank you, Doug, for the tap, 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 and for the roses. Thank you so much. I appreciate that. I appreciate that. Thank you, everybody. Thank you, everybody. How are we doing? So when we do 9, after 9 is 10. That's what 10 is. So 10 is a 1 and a 0. And then, for those of you that are interested, oh, I wonder if Allie is... Hello, Allie. I wonder if she's going to be on. If for those of you that are interested in... oh, I need a headset. For those of you that are interested in coding, Allie does coding. I don't know if she's going to join. Hello. Oh, no, she didn't join. That's okay. Whoops. Nope. Wah, wah. All right. So, thank you everybody for joining. How are we doing? Anybody have any specific questions for the app? I do have these books available in my TikTok shop. So what we're going to do is we're going to continue on with, what are we doing? What shall we do today? Shall we do some, let's do some reading. There we go. So we have our number. Here is my Abacus book. This Abacus book is available in my TikTok shop. This is a 4-digit abacus. What we're going to do is we're going to focus on, or I can do a walkthrough. Oh, you know what? Let's do a walkthrough of the adult book. For those of you that are interested, I do have an abacus for adults. And that's what this is. And so what we do is we actually talk about how to, hold on, there we go. Basic math, Abacus. So this is for adults, and what I did was I broke up into a point where I give you I give you instructions on how to read the abacus. I give you the idea of how to count from 1 to 100, and then we have a review of what the tens are, and then we have the masked maze. So what we do here is maze. We want to find what the answer is, and we want to know what the answer is on the abacus, and then you find the answer that's on the path. Thank you so much for joining, everybody. Thank you so much for joining. But if you notice, it'll be easy for you to see what the answer is. So I give you the option to have this masked maze. This masked maze is to help prevent you from looking at the answers around the abacus. But you do have the option to download it like this. You can download it so you can put it on a thicker piece of paper, because then you can do that. So what number, for those of you that just joined and was wondering, let's see what number we think this is. So we have our tens and we have our ones. We have our tens and we have our ones. What number do you think this is? Thank you so much for liking the live, everybody. Thank you so much for liking the live. I do appreciate it. What number do you think this is? Is it 81? It is 81. Well done, Muted. Yes, it is 80. It is 1. So then you have to find the path that will take you to 81 to the next one. So then I feel like I'm the only 3 people liking this live. I know, I do. I feel the same way, Jess. I feel the same way. This is 3 digits, and so I explain to you what 3 digits look like. This is 100 on the abacus. We have our ones, our tens, our hundreds. This is what 100 looks like. This is what 101 looks like. 101 looks like that, and then we have 110. 110 looks like that. 110. And then I explain again how it breaks it up into the abacus. We have 5, 4, 7. So we have 500, 547. That's what it would look like. So on the abacus, that's what 547 looks like. And then we start going into the mask maze. Again, the maze, right? It would be nice to have it to cover up the path. So what number do you think this is? We have our hundreds, our tens, and our ones. What number do we think that is? Thank you so much for liking the live, everybody. Thank you so much for liking the live. Thank you, Doug. It is 863. Well done. Well done. Yes, thank you. 800. 5 plus 3 is equal to 8. 5 plus 1 is equal to 6. And then there's 3. 1, 2, 3. So that is a little bit about the maze itself. And then you have the next one, which is a 4-digit number. The 4-digit number is 1, 2, 3, 4. Is the thousands. So thousands would look like that. That's what thousands would look like. If I say that this is my ones place, because my ones is where my dot is, this is a label where the ones is. So my ones, my tens, hundreds, and thousands. And then we have 1001. That's what 1001 would look like. And then we have 1100. 1100 looks like that. 1100. Right? And so I give you another set of maze. This is what I call a reverse maze. I give you the path, and the idea is for you to color in what the abacus is. So if this is 5,847, you're supposed to color in 5,847. And then we start talking about how to add on the abacus, simply adding and simply subtracting. And then there is this pixel art. This pixel art was meant to I know it's super easy with the pixel art, but the idea was to see what it would look like to move the beads. So if we have 7 on the abacus, I want to add the 2. To add the 2, all I got to do is add the 2 like that. So my final answer is 9. So you'd color in this, and then you'd figure out what this picture is. Another pixel art. And then we have adding of the 5, right? Adding of the 5. And then I give you some examples of how to add the 5, and then we have subtraction of the 5. And then after that, we do minus the 5, and then we have, after that, minus the 5, and then we have the hidden words. After the hidden words, this is a summary of adding of the 5 and subtracting of the 5, meaning that if I know how to add the 4, I know how to subtract the 4. That's what that means. And then we go into carrying over. After carrying over, I don't have that. There it is. Here we go. After carrying over, we talk about how there's example questions, and then I give you activities. This is a color by number, and then we do repeated addition. In Abacus World, for multiplication, we do repeated addition. So the only thing that we need to do is from 1 to 4 for this one, and then we have the word ladder and more examples, and then I have the 5 times table, write the formula if you used it, and then we have our next one, which is minus the 10. Because if you know how to add the 10, you know how to subtract the 10. Subtracting the 10 means what? Subtracting the 10 means to borrow, right? And so when we're looking at it, that's what this is. So we're borrowing the 10 from the previous number. And then we have the color by number. I give you an option to write the formula and then your color key. And then there's the word ladder, and then here's the summary. The summary is how to make how to add the 8, add the 9 and minus the 9. So I give you the summary of how to add and subtract, and then we have a workflow. This workflow is how do you read the question to make it make sense. So this is where you get to critical thinking. Critical thinking is, do you have enough beads? If you have enough beads, then you add it or you subtract it. If you don't have enough beads, then what you're going to do is you're going to add the 5. If you don't have anything to add the 5, then you're going to have to add the 10. That's what you're going to have to do. And it's the same thing. If you do it on the addition, you're going to do the same thing with subtraction. Do you have enough beads to subtract? Do you have the minus 5 to subtract? If not, then you're going to have to use the 10. And so then we have a plus 2-step equation. The 2-step equation means that you're actually going to take how to make a 5 and how to make a 10, and you're going to combine the two. That's what that means. You're going to like Tetris your way through. And so that's the final step of understanding how to add and subtract. Because once you know how to add and subtract, then you can add and subtract at scale. So it actually doesn't matter where you are on the numbers. No matter how big the numbers are, you'll be able to add it. I give you activities. So here's a puzzle. Answer the puzzle, and then find the puzzle piece. Here is the formula where you can write. You have space to write the formula, and then we only go from an Abacus World. We only go to 9 times table, because anything after that we do distributive property, and it's just being redundant. So we don't need to be redundant, and we don't need to memorize anything higher than 9 times 9. Even like 12 times 12, we don't need to memorize that, because what we do is we do distributive property. So, how are we doing? And then after that, we go into minus the 2-step equation, and then understanding that this is a 2-step equation, you'll see the flexibility, and then that goes into multi-step equations. Again, we do the puzzle. We have adding of the puzzle. We have the puzzle, find the answers, and then, solve the problem, and then find the answers. Cut it, and then if you want, you can also write the formula. I give you a mosaic, and then mazes, and then hidden words. 50,000, that's awesome. Thank you so much, Jess. Thank you so much for the reminder. I gotta pin that. Thank you. Oh, we should celebrate. We should totally celebrate. Let's celebrate. There we go. I will dance for you guys. Thank you so much. Thank you so much, Jess. Thank you so much for the roses. Thank you so much. We're just dancing because we just reached to 50,000 likes. Thank you, everybody. Thank you. And so this is, and then color by number and addition, and then that's it. So these are all practice, and it goes up to thing. Got you. We made it. We did make it. We did make it. Thank you, Doug. Thank you. Thank you, Jess. I do have the answers in the back of the book as well, for those of you that are interested. Thank you so much. I do appreciate it. So, how are we doing? We're all right? It's been a long night. Okay, so we're going to do a review one more time. Here is my Abacus. An Abacus is a counting tool. It helps you visualize your numbers. Thank you, everybody, for joining. We can count on the Abacus. We can count 1, 2, 3, 4. This is 5. We have 6, 7, 8, and then 9. After 9, we have 10. 10 is a 1 and a 0. We have 11, 12, 13, 14, 15, 16, 17, 18, and then 19. So 20 is a 2 and a 0. And then you might be wondering, well, what's after that? Well, we have our hundreds, we have our thousands, and then there is 10,000s. There we go. How are we doing? I know it's late. I know it's late. You guys are crazy. This is nuts. I'm surprised that everybody's still here. I have like 152 people in my room, and we're just reading the Abacus, and I'm dancing. All right, let's do, how about this one? How about this one? Oop. What's that? Oh, no, that's boring. What if I did this one? Ah, there. We've seen that one before. What else? We could do this one. The gingerbread. No, I don't like that one so much. No, I'd rather do this one. Okay, so how are we doing? Oh, thank you so much, everybody, for joining. Thank you so much for joining. What we did is we reviewed the Abacus, and we're understanding how to read it. After we learn how to read it, we're going to go into adding and subtracting. So let's do a little bit of that, or we could do some. Should we do some? What? We did a little bit of multiplication. We're going to go into adding and subtracting. So what we're doing is, you know what? I wonder if this would be easier to go from the tens. So here, we're going to do is a plus 10. On the Abacus, we're going to do 7. 7 plus 7. So on the Abacus, if I add the 7, so I have, there we go. So we have 5, 6, 7, 8, 9. Let's do 9, right? 9 plus 7. Now, on the Abacus, when we look, we have 9 on the Abacus. What is the question? The question is over here. I don't know if you guys can see that. The question is 9 plus 7. There it is. So on the Abacus, I have 9, right? But what I want to do is I need to add 7. Notice I have no more room to add 7. Because I have no more room to add 7, I need to do something. I know to make a 10, all I got to do for 7, I need to add a 3. I have to find the 3 from somewhere. Thank you, Robert. It's a celebration of getting to 50,000. That's what it is. It's a celebration to get to 50,000. So we have 7 plus 3, right? 7 plus 3. 3 will get me to 10. But we got to get the 3 from somewhere. The 3 will come from the previous number. The 3 will come from the 9. So what we do is we take away the 3 from the 9 like that. So we take away the 3 from the 9 like that. So we take the 3 from the 9, and then we add it to the 7. That is how we make a 10. So what we just did is we made a 10, so we show it on the Abacus. We made a 10. So that's the formula. The formula is when you add the 7, when you need to add the 7, you need to subtract a 3 from the previous number, and then you can add the 10. Does that make sense? So what we just did is we did a concept. The concept is how to make a 10. We don't count up. We're not counting up. What we're doing is we're using a concept because we already know what 7 is, and we need to use the complementary numbers. And the complementary numbers is 7 plus 3 is equal to 10. We know this, so we should use it. So what we're trying to do is we're trying to utilize the numbers, right, for what it is. We can do it again with the 4. So if we did 4 on the Abacus, notice when I do 4, 8 plus 4, not that one. Here we go. So we did 8 plus 4. I put 4 on the Abacus, right? No, I put 8 on the Abacus. Now, in mainstream world, what's really interesting is they'll always take the top number and they'll make that into a 10. But in Abacus world, we don't do that. The reason why is because we don't know where we're going to get the 2 from. We look at our question, we don't know where to get the 2 from. We know that we're going to add the 4. To add the 4, hello Kazar, thank you so much for checking in. Hello, we reached to 40, 50, almost 55,000 likes on this live. That's pretty amazing. That's really amazing. Thank you so much for checking in. For those of you that are interested, go ahead and check in on the orange heart me that's above where my hat is to check in to be a part of my community. So when we're adding the 4 on the abacus like that, right? We're adding the 4. Notice that we don't take the 5, we don't take the 9 to, we don't take the 8 to round up to 10. What we do is we take the 4 and we need to round it up to 10. Now what do? We know that 4 is equal to, we know that 4 plus 6 is equal to 10. So if we need to round up to 10, we got to find 6 from somewhere. The 6 is going to come from the 8. Here is my 8. So the 6 comes from here. Do you see that? This is what 6 is. 6 is taken away from the 8. So I take away from the 8 like that. And then I add it to my 4. So now I've made a 10. So my final answer is 12. And I've made a 10. My final answer is 12. And so what we just did is we rearranged and we regrouped our numbers. And that's how you regroup in Abacus world. How are we doing? Does that make sense? We can do it again. So notice in Abacus world, we go from top down. Why? Because we keep a running total. So when we have bigger numbers, we have a lot more numbers, we always go from the top down. We don't go up and down. But in Abacus world, we always keep a running total on our abacus. So right now it's a little easy because it's only 2 numbers, but when we get into like 4 numbers or 3 numbers, we always go from the top down. So like this, we have 9 on the abacus. We have 9 on the abacus. I want to add the 3. To add the 3, what do? I know my formula. My formula is plus 3 is equal to plus the 10 minus 7. So what do? I have to minus the 7 plus the 3 plus the 10. So my answer is 12, and then what do? I need to add the 6. To add the 6 is plus the 5 plus the 1, and you bring it together, and so my final answer is 18. Excuse me. How are we doing? Does that make sense? So what we're doing is we're understanding how to make a 10. That is what this book is. Hello, Blue Wolf. Hello, Blue Wolf. So, that's it right there. So, you have so much dedication. You're always on. Oh, thank you, Roman. I do appreciate that. My goal is to try to take over the world with Abacus.
Gee, babe, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
Hello, Miracles. Good evening. Good evening. Good morning. Good morning. Good morning. So, thank you so much. Thank you so much. I do appreciate the compliment. Thank you, Roman. We were just celebrating on the 50,000 Ks. Thank you so much. Thank you so much, everybody. How are we doing? All right. So, that's about it. I mean, I've been on for a little bit. Thank you so much, Miracles, for liking the live. Thank you so much. I do appreciate that. Can you explain to me what an abacus is? An abacus, the simplest definition of an abacus, it is a math tool that helps you visualize numbers. That's it. That's all it is. That's all it is. It just helps you visualize your numbers. So when we're looking, this number right here is actually 18 because there's a 1 here and there's 8 here. Gonna call it a night. Me too. Me too. Thank you so much, Jess. Thank you so much for sticking around and entertaining and being a part of it. Thank you. Have a great night. You too, Jess. You too. I'll see you in my next live. Have a good one. And hopefully you have a lot more art in you. Yeah? Thank you so much. Thank you so much. I appreciate that. Hello, Stephanie. I just woke up for a late night snack right now. See you later, Jess. See you later. Thank you, Stephanie, for checking in. Thank you so much for checking in. What kind of late night snack are you looking for? I've been a whole. Oh, that's all good. Making art. That's so awesome. That's so awesome. I'm so happy. I'm proud of you. I ate it. Oh, that sounds delicious, Stephanie. You ate an almond croissant? Oh, that sounds really good. What about like yogurt and stuff? That would be good too, yeah? Not my best, but I had a craving for it. Oh, interesting. Ah, so are we a bunch of artists here? I make music. Maybe? No? Because I think there's a few people that are math people. Like Robert is a calculus person. And then no, there's more like educators than anything. Or people who want to learn the abacus. Thank you, Miracles, for the follow. Yeah. Yeah, they were day old, so I that's the best. I do the same thing with fruit. I get the fruit. I'm in biomedical science, stuck with chem right now. Ah, there you go. I had a person came into my room yesterday and they were dealing with math and physics and they were making this whole new thing and I was like, that's really smart. I'm not that smart. I only know how to do the abacus. And then they were asking like how to if I knew anything else. Like, nope, I only know how to do basic arithmetic. All right. Thank you, everybody, for joining. Thank you, everybody, for joining. You know what? I am going to head out. I've been on for a little bit, and it is time to shut it down. Thank you, everybody, for joining. Thank you so much for joining, and I hope to see you all in my next live. Thank you. Literally checked in to see if you're on. I was on. I've been on for like 2.5 hours. And I'm like, okay, I'm getting a little tired. You could tell. Jen, you're still here. You were supposed to be asleep already. Jen, thank you so much for staying. You're so cool. Thank you, everybody. Thank you so much for joining. Thank you. Have a good night. Long time, but it's lots of learning. Oh, yeah. Yeah. It was pretty good. Yeah. Jen told me to do times to get to, yeah. That had to be, yeah. So we were trying to figure out, like, how many feet are there no. I didn't know how many feet was in a mile. And so then the next thing was how many yards was in a mile. And so I was told to multiply by 3, but it should have been divide by 3. So now I know. I'm going to blame it yards and foot. I'm going to blame it that I'm Canadian and I don't know how to do imperial math. And imperial math is backwards. And I don't know why we're doing it in America. As advanced as we are, I don't know why we haven't changed to metric system. Yeah. Yeah. So confusing. Yeah, if you get a chance, Jen, it's called Washington's Wish or Washington's Dream. It's an SNL skit. I hope you like it. It was so funny. I listen to it all the time. Yeah. Imperial math makes life so confusing. When I talk to many of my foreign friends, yeah, right? And you know what's really funny? Like there was a Mars expedition, and they actually crashed one of the satellites, or they actually crashed one of the rovers, because they forgot to, right? That was hilarious. And Nate, the comedian, he has such a great delivery. Oh, yeah. So the rover actually went to Mars, but it crash landed because somebody forgot to convert from miles to meters. And I don't even know why they're even using miles in science. But that was one of the excuses. They forgot to convert, and I'm like, how is that even possible? Science is all about metric system. We have to do homework for this. Yeah. Do we have homework for this? Yeah. Go watch. That's what your homework is. Homework is Washington's Dream. Is it Washington's Dream or Washington's? It's Washington's Dream, right? It's an SNL skit. That's your homework. I never used miles in any sign. I know. It was such a strange thing. It was such a strange, like, boof. Yeah. There's your homework. Washington's dream. All right. Thank you everybody for joining. Thank you everybody for joining. Have a good night. Have a good night, everybody, and have a good morning.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
It was a very expensive mistake. Yeah, millions of dollars. Crazy, right? So, thank you everybody. Thank you everybody for joining. Have a good night. Have a good day. Have a good morning. I will see you all in my next live, which will probably be tomorrow. I'm on daily, if not twice a day. But thank you again for joining. Have a good day. Have a good night. Bye, everybody. Thank you so much for joining. Thank you so much for the Bat Boy. Comprende? Comprendo. There we go. Compentrando. Compentrando. There we go. Bye, Jen. See you. We could do this one. Here is a little bit of music to let us go out. There we go. All right. Thank you, everybody, for joining. Thank you so much for joining. I will see you all in my next live. Have a good day. Have a good night. See you later. Bye, everybody.